Welcome. Tonight, our journey takes us to a place more alien than the surface of the moon. A place that exists right now on our own planet, this very evening, as you sit here in your comfortable room, yet remains almost completely unknown to the species that has mapped every continent and photographed every mountain. We are traveling down past the last glimmer of sunlight, down through the twilight realm where blue fades to black, down past the midnight zone where no photon from our star has ever reached, down to the deepest point of our world, the Mariana Trench. This is not just a journey into darkness, it's a journey into secrets, quiet, ancient secrets that have been kept for millions of years. We will explore the unidentified metallic sounds that echo from its walls, sounds that have no explanation and no known source. We will chase the phantom fish seen by the first explorers, a creature that may or may not exist, glimpsed for only a second and then never again. And we will meet the strange biological paradoxes that defy everything we thought we knew about life. Creatures of glass, so transparent they are almost invisible. Transparent hunters that glow with red light no other animal can see. Creatures that would simply melt, dissolving into nothing if brought to our world. And we will ask the quiet, unsettling question that haunts every explorer who has looked into that abyss. How did our own ghost, a simple plastic bag, a piece of discarded trash from a grocery store somewhere on the surface, manage to reach this untouchable place before we did? How did our garbage, our carelessness, our forgetfulness get there first? What does that say about us, about our reach, about the shadow we cast even into the deepest shadows of the earth? If you find this slow, quiet exploration of mystery something you genuinely enjoy, something that feeds a part of your mind that is rarely fed in our loud, fast, modern world, I would be genuinely grateful if you would like the video and subscribe. It is a small thing, a click, but it tells me that this quiet corner of the internet matters to you. And letting me know in the comments where you are listening from and what time it is for you, that small act of sharing your geography and your moment is always a quiet comfort. It reminds me that we are all alone together in this darkness, each in our own room, each at our own hour, but connected by a shared curiosity. Now, find your comfortable position, adjust the lighting, dim it low. Let the shadows gather at the edges of your vision. Take a slow, deliberate breath. Let your shoulders drop. Let your mind settle. We are leaving the map behind. We are going somewhere that cannot be found on any phone or any GPS. We are going into the blank space. That map, the one you carry in your pocket, the one that shows every street, every restaurant, every park, is an illusion. A beautiful, useful, but fundamentally deceptive illusion. We think of our world as a solved puzzle. In our minds, the globe is complete. We have satellites that can chart every street, every river, every remote mountain peak. We photographed the entire surface, every continent, every island, every ice cap. We have sent probes to Mars and Venus and the moons of Jupiter. And we tell ourselves, with a kind of quiet pride, that there are no more blank spaces, that the age of exploration is over, that the world is known. But that is the great lie of the surface. That is the deception of the map. Our true maps, the ones that show the reality of the planet we actually live on, stop at the water's edge. They end at the shoreline. And when they do try to show what lies beneath, what lies in the 71% of our planet that is covered by salt water, they are mostly guesswork. Artistic renderings. Vague, low-resolution sonar scans that paint the ocean floor in broad, blurry, uncertain strokes. We know more about the far side of the moon than we know about the bottom of our own ocean. That is not an exaggeration. That is a fact. The Mariana Trench is the ultimate proof of this. It is a 2,500-kilometer-long scar on the planet's surface, a crescent-shaped gash in the crust of the Earth, wider than the Grand Canyon, deeper than Mount Everest is tall. And it has stubbornly, absolutely, completely resisted our attempts to truly see it. We have sent human beings there only twice in all of human history. 2 descents, a handful of visits by robotic probes. That is the sum total of our direct observation of the deepest place on our own planet. The reason for this ignorance is simple, and it is absolute. It is a word we use lightly, but whose reality we rarely grasp. Pressure. At the surface, we live under a gentle, comfortable blanket of air. We forget its weight. We move through it without thinking. But travel down into the ocean, just a few meters, and that pressure begins to build with a crushing, relentless, unforgiving logic. For every 10 meters you descend, another entire atmosphere of weight is added to you. Another complete layer of pressure pressing in from all sides. Now imagine descending 7 miles, 11,000 meters. That is the depth of the Challenger Deep, the lowest point of the Mariana Trench. At the bottom of the trench, the weight of the water above you is over 1,100 times greater than at the surface. Let that number sit with you for a moment. 1,100 times the pressure you are feeling right now. The air around you, this invisible, weightless seeming thing, is actually pushing on your body with about 15 pounds per square inch. At the bottom of the trench, that same square inch would feel over 16,000 pounds of force. This pressure is an inverted force. It is a weight that comes from every direction at once. It warps solid steel as if it were paper. It pulverizes bone into dust. It compresses matter so intensely, so fundamentally, that it changes the very laws of chemistry and biology. Materials that are rigid and strong on the surface become flexible and strange down there. Air pockets, even the tiny bubbles trapped in the bones of a mammal, would be crushed into nothing. This is why the moon was easier. Think about that. The moon is 250,000 miles away. It is a vacuum, a lifeless, airless void, a place of extreme temperatures and no atmosphere. But it was easier, because the moon was a void we had to fill with our own technology, our own life support, our own air. It was a problem of addition. We had to bring everything we needed. The trench is the opposite. It is not empty space. It is not a void. It is an overwhelming presence, a force that pushes back, a weight that resists, a power that must be held at bay by every weld, every seal, every inch of reinforced steel. The trench is a place that is trying to kill you every single second, not with poison or teeth, but with the simple, indifferent, absolute weight of the world. And this is what makes the map blank. Not because the trench is empty. It is not empty. It is full of life, full of sound, full of mystery. But because it is so incredibly, unimaginably full of this power, this pressure, this force that we were never built to withstand and have only barely learned to endure for short periods. It is a place that holds its secrets not with locks or guards, but with physics, with the fundamental, unyielding laws of the universe. We cannot go there easily. We cannot stay there long. And so, the secrets remain. When we imagine that depth, that crushing, total, absolute darkness, we usually imagine one other thing: silence. A perfect, absolute, eternal quiet. The kind of stillness that must surely exist where no light has ever reached, where no warmth has ever been felt, where no sound could possibly travel. We picture an empty void, a dead space, a silent kingdom of cold and dark. We picture the end of noise. But that assumption, like the map, is wrong. It is not just wrong. It is spectacularly, surprisingly, hauntingly wrong. One of the most surprising discoveries about the Mariana Trench, one that fundamentally changed our understanding of the deep ocean, is that it is not silent. In reality, it can be one of the noisiest places on Earth, not with the noise of traffic or birds or human voices, but with a deeper, stranger, more ancient symphony of sound. In recent years, scientists have lowered highly sensitive, titanium-encased microphones called hydrophones into the abyss. These are not simple underwater listening devices. They are marvels of engineering, designed to withstand pressures that would shatter conventional equipment, built to detect the faintest whispers of sound in a realm we assumed was mute. They were expecting to record a baseline of quiet, a kind of acoustic zero, the sound of nothing. Instead, their instruments were flooded with sound, a constant, low, rumbling chorus of noise from sources near and far, from the surface and from the deep, from the living and from the geological. The reason for this is physics, but it is a strange and beautiful branch of physics. The unique combination of pressure, temperature, and salinity at certain depths in the ocean creates what oceanographers call a deep sound channel, or SOFAR channel. Think of it as a natural fiber optic cable for sound, a layer of water where sound waves slow down, get trapped, and cannot escape.
This channel acts as a massive, planet-wide natural amplifier. Sound that enters it does not spread out and fade away as it normally would. Instead, it is contained, guided, and carried. It travels horizontally for thousands of kilometers across entire ocean basins, losing almost no energy. A whisper in the deep sound channel can be heard on the other side of the world. And what did these hydrophones hear, suspended in this channel within the Mariana Trench? First, they heard the Earth itself, not as a metaphor, but as a literal, audible presence. They heard the constant, low-frequency groan of the tectonic plates grinding against each other, the very sound of the trench being formed, the sound of the Pacific plate being forced under the Philippine plate, the sound of the Earth eating itself and being reborn. They recorded the deep, distant rumbles of underwater earthquakes from half a world away, sounds that travelled through the channel for thousands of miles before reaching their microphones. They also heard the ghosts of the surface, the distant, churning, rhythmic thrum of a supertanker's propellers passing miles above in waters that seemed so far away was captured as a constant, haunting hum, an industrial heartbeat that never stops. Even the sound of a typhoon raging on the surface, wind and waves and chaos, its energy penetrating all the way down through the miles of water, was recorded as a deep, shuddering roar.
But most haunting of all, most beautiful and most strange, they heard life. The low, complex, evolving songs of baleen whales, echoing from oceans away, funneling into the trench, bouncing off its walls. A single whale's call, trapped in the deep sound channel, can travel across an entire ocean basin, from the Atlantic to the Pacific, from the Arctic to the Antarctic. The trench, it turns out, is not a silent tomb. It is a planetary echo chamber, a place that remembers and carries almost every deep sound the world makes, from the groan of the Earth's crust to the song of the largest animals to ever live. Those sounds, the Earth, the ships, the whales, are the ones we can identify. They are the known voices in the symphony. But the recordings that truly puzzle researchers, that keep them awake at night, that appear in scientific papers with cautious, careful language, are the anomalies. The sounds that do not fit a known pattern. The sounds that have no origin. The sounds that seem to come from nowhere and nothing we can name. For decades, the most famous of these was a sound called the Bloop. It was an ultra-low frequency, extraordinarily high amplitude sound recorded in 1997 by hydrophones thousands of miles apart. It was so powerful, so distinctive, that for several years it was the perfect candidate for a deep sea creature. Something far larger than even a blue whale. Something that made a sound loud enough to be heard across the entire Pacific. The internet, as it always does, named it a monster. The truth, when it finally came, was almost as interesting. Scientists eventually traced the Bloop not to a living thing, but to the catastrophic, violent cracking and breaking of a massive ice shelf in Antarctica. It was the sound of ice, not a monster. The sound of a continent calving, a geological event, not a biological one. But the Mariana Trench has its own stranger symphony, and it remains unexplained. In 2014 and 2015, researchers deploying deep-diving floats, autonomous underwater vehicles designed to sink to the deepest depths and then return, recorded something new in the waters of the trench. A sound they simply could not explain. It was a bizarre, complex, 5-part call, lasting just over 3 seconds. It started with deep, resonant groans, like a foghorn heard from a great distance. Then, in the middle of the call, it suddenly, dramatically leapt into a high-pitched, almost metallic, almost electronic-sounding twang. It sounded like nothing else in the known acoustic catalogue of the ocean. They called it the Western Pacific Biotwang. It is a name that sounds almost playful, but the mystery behind it is not. They listened again and again. They analysed the frequencies, the duration, the pattern. It did not match any known whale species. It did not sound like any geological event, any shifting of rock or movement of ice. It was complex, repetitive, patterned, and seemed, for all the world, like a signal, like communication, like something trying to be heard. To this day, the leading theory, and it is presented with great caution and many caveats, is that it might be a new, undiscovered call of a minke whale, a species we know exists, but whose full vocal repertoire we have never fully documented. But it is just a theory. It is a guess. No one has ever seen a minke whale make this sound.
The sound's mechanical, metallic quality, its sudden shift in pitch and timbre, does not sound like anything a whale is known to produce. And so the biotwang remains a mystery, a sound from the deep, from a source we cannot see, cannot identify, cannot explain. And then there are the other reports, the unconfirmed, almost anecdotal stories.
The kind of stories that submarine crews tell each other in quiet moments. The kind of stories that deep sea researchers mention in interviews and then quickly qualify. The sound of clanking metal in a place where no metal should be. Not a natural sound, not a geological sound, but the sound of one piece of metal striking another like a hammer on a pipe. The sound of organized, rhythmic tapping like a signal from the darkest, most remote part of the abyss. Are these just the echoes of old shipwrecks, the settling of steel hulls on the seabed, the random noises of degradation and decay? Are they the clatter of rocks in a submarine canyon, a landslide happening in slow motion under the crushing weight of the water? Or is something else down there, something that makes sounds, something that taps, something that wants to be heard? The trench, it seems, is very good at keeping its more unusual noises a secret. It gives us just enough to be curious, just enough to be unsettled, and then it falls silent again, waiting. That is the question that haunts us, isn't it? When we hear an unknown sound from a place we cannot see, our imagination rarely paints a small, simple picture. It tends, instinctively, almost uncontrollably, to imagine something large, something powerful, something that could make that sound, something that might be looking back. In the modern world, in our era of CGI monsters and viral internet mysteries, there is one specific giant we love to imagine in the deep. A shadow that has swum from prehistory, from the fossil record, from the pages of natural history books, into popular culture, into movies, into documentaries, into the speculative corners of our collective imagination. Megalodon. The name itself is thrilling. Megalodon. Giant tooth. The idea is a powerful one, almost irresistible in its appeal. That a 60-foot shark, an apex predator from a bygone era, a creature that dwarfed the great white and made the killer whale look like a snack, could have survived. That it simply fled the cooling surface waters of the ice ages, the changing climate, the disappearance of its preferred prey, and found refuge in the one place on Earth we have not fully checked, the one place where it could hide, the one place we cannot easily go. The deep, the trench. It is a beautiful idea, it is a thrilling idea, but it seems to be one secret the trench does not keep. The science itself, the cold, hard, indifferent science, presents a difficult, perhaps insurmountable barrier. A creature like Megalodon, a massive, warm-bodied, fast-moving predator, would have needed a staggering amount of food. Not just a meal now and then, but a constant, reliable, abundant supply of large prey. Whales, large fish, other sharks. The deep ocean, by contrast, is often described by marine biologists as a food desert, an economic zone of starvation. Life there operates on a budget of extreme scarcity, mostly surviving on the sparse, nutrient-poor marine snow that drifts down, slowly, thinly, from the productive surface waters above. A megalodon, a warm-blooded leviathan requiring thousands of calories a day, would not just struggle. It would starve. It would simply, inevitably, run out of energy and die. The evidence for its survival, in the form of modern teeth or fresh remains, is non-existent. We find fossilized megalodon teeth by the thousands, embedded in ancient seabeds, in coastal cliffs, in the fossilized stomachs of prehistoric whales. We do not find them in the deep. We do not find them anywhere near the trench. If a population of 60-foot sharks were living down there, reproducing, dying, losing teeth, we would see the evidence. We do not. And yet, the idea of giants in the deep is not wrong. It is not a fantasy. In fact, it is one of the strangest, most unexpected, most fascinating truths of the abyss. While the trench may not be hiding the giants of the past, the relics of prehistory, it appears to be actively, right now, in our own time, creating new ones. In the dark, in the cold, under that relentless, crushing pressure, a biological mystery occurs, a phenomenon that still does not have a complete scientific explanation. It is called deep sea gigantism. It is a phenomenon where creatures that are small and insignificant on the surface, in the shallows, in the sunlit world, creatures like shrimp, like lice, like amphipods, evolve over time, over generations, into slow, lumbering, pale, and unusually large versions of themselves. The familiar becomes the strange. The small becomes the giant. The common becomes the extraordinary. So the fantasy of a giant, the deep-seated human expectation that the unknown holds something large, is not incorrect. It is, in a sense, correct. But we may have been looking for the wrong kind of giant. We were looking for a shark, a predator, a monster from the past. But the trench does not support those. The trench does not have the energy budget for fast, warm-bodied, high-metabolism hunters. Instead, it fosters a different kind of giant. Slow, patient, pale, adapted not to speed and power, but to endurance and scarcity. A giant that has achieved its size not by eating everything in sight, but by living a very, very long time, by growing slowly, by never receiving the biological signal to stop. But those true giants, those pale, slow, patient creatures of the deep, were unknown to us for the longest time. They remained hidden, not because they were small, but because they lived in a world we could not reach. Because to find them, we had to do more than send microphones, more than lower cameras, more than speculate from the surface. To find them, we had to go ourselves. We had to build machines that could survive the pressure, that could carry human beings down into that crushing darkness, and we had to have the courage to get inside them. In 1960, 2 men did just that. Their vessel was the Trieste, a name that sounds almost Mediterranean, almost gentle, but the machine itself was anything but. It was a Swiss-designed, American Navy-owned bathyscaphe, a word that comes from the Greek for deep ship. It was a novel, strange, almost experimental design, a massive float, over 50 feet long, filled with thousands of gallons of gasoline. Gasoline, because it is lighter than water, and, critically, because it resists compression. Even under immense pressure, gasoline remains gasoline. It does not implode. It does not change volume the way air would. Hanging underneath this giant gasoline-filled float was a tiny, reinforced steel sphere just over 7 feet in diameter, barely larger than a refrigerator. Its walls were 5 inches thick. Solid steel. A sphere, because a sphere is the strongest shape against external pressure, distributing force evenly across its entire surface. Inside that sphere, barely large enough for them to sit, their knees drawn up to their chests, their movements restricted, their world reduced to a tiny, cramped, steel-walled capsule, were 2 men. Jacques Piccard, a Swiss engineer and oceanographer, the son of the balloonist who had taken the first humans into the stratosphere, and Don Walsh, an American Navy lieutenant, a submariner who understood the risks of depth. Their mission was simple in its statement, almost impossible in its execution. To be the first human beings to touch the deepest floor on Earth, the Challenger Deep, the bottom of the Mariana Trench. The sphere was designed to withstand the pressure. It had been tested, theoretically, mathematically, on paper. But no one really knew if it would hold. No one had ever built anything like this before. No one had ever subjected a human-occupied vessel to these kinds of forces. The calculations were theory. The trench was reality. And reality has a way of ignoring calculations. The descent was slow, excruciatingly slow. It took almost 5 hours. 5 hours of falling through darkness, through water that grew colder and darker and more crushing with every meter. They fell through the last glimmer of sunlight, past the twilight zone where colors fade to blue, past the midnight zone where no light from the surface has ever reached, into a blackness so absolute, so complete, that it was not just the absence of light, but a physical presence, a weight, a pressure not just on their bodies, but on their minds. And then, at over 30,000 feet, nearly 10,000 meters down, with the pressure outside their tiny sphere reaching over 15,000 pounds per square inch, it happened. A sound that no one in human history had ever heard at such a depth. A single, sharp, and very, very loud crack. It was not a creak. It was not a groan. It was not the settling of metal.
It was a clear, unmistakable, structural bang, a sound like a gunshot, a sound that shuddered through the entire vessel, through the steel sphere, through the gasoline float, through the bones of the two men inside. In that moment, they were the two most isolated human beings on the entire planet, suspended in total, absolute darkness, 7 miles from the sun, over 30,000 feet above any other human being, with no hope of rescue, because at that depth, rescue is not a concept. There is no emergency procedure for a failed hull at the bottom of the trench. There is only death, immediate, absolute, crushing death. And they had just heard what sounded exactly, precisely, terrifyingly like their tiny sphere failing. For a long, tense, silent moment, they watched their instruments, their eyes scanning the gauges, the dials, the displays, checking for a leak, a change in pressure, water on the floor of the cabin, anything. Their hearts pounding in the silence, the seconds stretching into minutes. Nothing. The pressure held, the sphere held, the crack had not been the hull. They eventually discovered the source. It was not the main structure. It was an outer plexiglass window, a small viewport on the entry tube that connected the sphere to the rest of the vessel. A non-structural piece, never designed to bear the full force of the abyss, had finally surrendered to a pressure it was never meant to withstand. It had cracked loudly, violently, but it was not essential. The inner sphere, the one keeping them alive, the one with 5-inch steel walls, was holding. They made a decision. It was a decision that defined them, that separated them from those who would have turned back. They did not ascend. They did not abort the mission. They kept sinking.
Pushing on, past the point of known engineering, past the point of tested safety, into the absolute, uncharted, unknown. Deeper and deeper, until, hours later, their small craft settled gently onto a fine, pale, creamy silt. They had landed. They were on the floor of the Mariana Trench, the deepest place on Earth. The silence that followed that violent, window-cracking bang was now a different kind of silence. Not the silence of emptiness, but the silence of arrival. The silence of a place that had never, in all of geological time, been touched by a human presence. The silence of a world that did not know we existed. Outside their tiny viewport, the cloud of fine, pale silt stirred up by their landing began to slowly, gently settle, like snow falling in reverse. They switched on their powerful external lights, mounted on the outside of the sphere, cutting the first man-made cone of white into a darkness that had existed for eons. The beam cut through the murk, illuminating the water, the drifting particles, and finally, the floor. The world they saw was simple, stark, almost unearthly in its barren beauty. A flat, pale, undisturbed plain of what looked like fine, creamy mud. No rocks, no plants, no coral. Just an endless, gentle slope of sediment that had been falling, particle by particle, for millions of years. The floor of the world, the bottom of everything. And then, in that small, circular beam of light, something moved. Both men, Pickard and Walsh, independently, clearly, repeatedly reported it. They saw a creature. It was not a sea cucumber. It was not a worm. It was not a jellyfish. It was, they insisted, a flatfish. Something like a sole or a flounder, about a foot long, pale, with the characteristic shape of a flatfish, a bottom-dwelling fish with both eyes on one side of its head. It had eyes. It looked at their light, turned, and then, disturbed by their arrival, it swam slowly away, its body undulating, disappearing back into the darkness from which it had come. On the surface, when they reported this, it was a revolution. It was not just proof of life at the deepest depth. It was proof of complex vertebrate life, a fish, an animal with bones, with a skull, with a spine, with a nervous system, with eyes that could see, thriving under a pressure that, according to every biological theory of the time, was supposed to make such advanced life impossible. The textbooks would have to be rewritten, or would they? In the decades since that first historic dive, that flatfish has become a ghost, a persistent, haunting, deeply unsettling scientific controversy. No other mission. Not James Cameron's solo dive in 2012.
Not any of the dozens of robotic probes, the remotely operated vehicles, the landers, the cameras that have since visited the Challenger deep. No one has ever seen another one. Not a single photograph. Not a single second of video. No vertebrate fish has ever been captured, on film or in a sample, at this, the absolute maximum depth of the ocean. The scientific consensus today, offered with respect to the men who made that first dive, but based on the weight of all subsequent evidence, is that Pickard and Walsh were most likely mistaken. The pressure at that depth, we now believe, is simply too great. At 11,000 meters, the force is so extreme, so fundamentally disruptive to biological chemistry, that it can inhibit the very proteins and calcium structures that vertebrate life depends on. A fish's cells, its membranes, its enzymes, its very molecular architecture would struggle to function.
The current understanding is that the maximum depth for a bony fish is somewhere around 8,000 meters. The snailfish, the ghostly creature we will meet later, holds the record. But even it does not live at the very bottom of the Challenger deep. So what did they see? What did those two men, the only human witnesses, the only eyes to ever look out at that pale silt, actually see? The most likely candidate, scientists argue, was a sea cucumber, an invertebrate, a relative of starfish and urchins. Some species of holothurian that live in the deep ooze can be pale, flat, and use small, fin-like appendages to swim in a slow, undulating way that could, in the dim light, in the stress of the moment, after a 7-mile descent and a window-cracking bang, have been mistaken for a flatfish. But the men who were there, the only two human beings who have ever looked out at that landscape with their own eyes, never backed down. They were interviewed many times over the following decades. They wrote reports, they gave lectures, and every time they insisted on what they had seen. They knew the difference between a fish and a sea cucumber, they said. They were trained observers. They had spent their lives on and under the water. They knew what a fish looked like, and they saw a fish. And so the mystery remains. A quiet, unresolved, almost forgotten ghost story at the bottom of the scientific literature. Were they wrong? Was it just a pale, slow-moving invertebrate, their minds understandably shaken after a descent that cracked their window and threatened their lives? Or did they get a 1-second, fleeting, unforgettable glimpse of a true vertebrate that has somehow, in some way we do not yet understand, broken the laws of biology? A phantom fish that lives at the deepest place on Earth and has simply, for the last 60 years, refused to be seen again? That first dive in 1960 cracked the door open. It proved that human beings could reach that depth and survive. But it would be more than 50 years before another human being returned to that specific, deepest spot. Half a century of waiting, of technological advancement, of robotic exploration. And then, in 2012, a new vessel, a new explorer, a new kind of mission. This time, the vessel was completely different. It was not a clumsy, balloon-like bathyscaphe, a gasoline-filled float with a tiny sphere dangling underneath. It was a sleek, futuristic, 24-foot-long green torpedo. Streamlined, engineered to fall, not float, to cut through the water, to descend rapidly and efficiently. It was the deep-sea Challenger. And inside, there was not a crew of two, there was only one. In 2012, the film director James Cameron, a man long obsessed with the ocean, with deep-sea exploration, with the mysteries of the abyss, decided to complete the journey his predecessors had started. But he wanted to do it alone. He wanted to be the first person to reach the Challenger deep solo. He spent years designing the submersible, testing it, funding it with his own money. And then, on a March morning in the Pacific, he climbed inside. His descent was, in contrast to the Trieste's slow, cautious fall, fast and modern. He fell through the darkness at a rate of 500 feet per minute, a controlled plummet, the water rushing past his viewport, the light fading from blue to indigo to black. But the psychology of the journey, the inner experience, was perhaps even more intense than what Pickard and Walsh had felt. Imagine the isolation. The Trieste crew had each other's presence to anchor them. Two voices, two bodies, two minds in that tiny sphere. They could talk. They could check each other's instruments. They could share the fear and the wonder. Cameron had only the hum of his electronics, the occasional crackle of the hull, and the sound of his own breathing, his own heartbeat, his own thoughts. He was encased in a steel sphere so small he could not fully extend his arms. His knees were tucked to his chest for hours. He could not stand. He could not stretch. He could only wait. As he fell, he was not just leaving the world behind. He was leaving humanity behind. He was descending past the realm of ships, past the realm of whales, past the realm of all other human beings. He was becoming, literally, the most isolated human being on the entire planet. More isolated even than the astronauts on the International Space Station, who could at least look down through their windows and see the blue and white curve of the Earth, who could talk to mission control in real time, who knew that home was only a few hundred miles away. Cameron looked out his tiny, thick, reinforced viewport and saw only crushing, featureless, total, absolute black. Not the black of night, which still contains stars, still contains the moon, still contains the distant lights of cities. The black of the abyss, which contains nothing, no light, no reference points, no up or down except what his instruments told him. Just an endless, formless, ancient darkness pressing against his window. He described the feeling in later interviews, not as fear, not as panic, but as a profound, almost philosophical solitude. A kind of loneliness that went deeper than emotion, that touched something existential. He felt, he said, a sense of presence. Not a living presence, not a conscious presence, but a presence nonetheless. The deep, quiet, overwhelming weight of a place that was not meant for him. A place that was utterly, completely, absolutely indifferent to his survival. He was a visitor, an intruder, a brief and fragile flicker of warmth and light in a cold, dark, and ancient eternity that had existed for billions of years before him and would exist for billions of years after him. That profound, alien solitude was not the only thing James Cameron found at the bottom of the world. He was there as an explorer, yes, but also as a filmmaker, a storyteller, a man who had made movies about the ocean, about the deep, about the unknown. He was hoping to capture an image, a video, a moment of something new, a strange life form, a bizarre geological feature, a hydrothermal vent, anything that would define this deepest of frontiers, that would give the world a glimpse of a place almost no one would ever see. He did find something that defined the frontier, but not in the way he or anyone else had hoped, not in a way that brought wonder, in a way that brought a quiet, sinking, deeply uncomfortable realization. As his powerful external lights scanned the pale, silty floor of the most remote, most inaccessible, most untouched place on planet Earth, the place farthest from human habitation, the place least likely to have ever been affected by human activity, he saw it. The beam of his light, the first light ever to illuminate that particular patch of mud, fell upon an object. It was not a rock. It was not a strange animal. It was not a mineral formation. It was a plastic bag. There, 7 miles down, in a place that had resisted humanity for all of geological time, in a place that had required the absolute limits of human engineering, courage, and wealth to reach, in a place that had only been visited by 2 other human beings in all of history, was the casual, immortal, unmistakable signature of our own carelessness. A simple piece of trash. A plastic bag, the same kind you might get at a grocery store, crumpled, drifting, settled on the bottom of the deepest trench on Earth. Think about the weight of that discovery. Think about the implications. We had barely managed to send 2, and then 1, human being to this spot. It had taken decades of planning, millions of dollars, state-of-the-art technology, and immense personal risk. And yet, our garbage had gotten there first, effortlessly, quietly. Without any planning or expense or risk, it had simply sunk. A piece of plastic, designed to be used for a few minutes and then discarded, had drifted down through the darkness for weeks or months or perhaps even years until it settled on the bottom of the ocean. A synthetic ghost, a piece of our disposable culture arriving before we did. This discovery was not dramatic. It was not a monster or a treasure, but it was, in its quiet way, one of the most unsettling realizations of the entire expedition. It proved that there are no more truly blank spaces on the map. It proved that the age of exploration, the idea that there are still untouched places, pristine wildernesses, is an illusion. It showed that no place, no matter how deep, how dark, or how crushingly hostile to human life, is safe from our influence. Our reach has exceeded our grasp. We have thrown a net of plastic and pollution around the entire planet, and the deepest trench is not immune. It is, perhaps, the final collection point. The most alien place on Earth, the place that seemed most like another world, suddenly felt uncomfortably, intimately familiar. It was no longer a pristine abyss. It was our reflection. It showed us ourselves. It showed us that we are a species that contaminates everything we touch, even the things we have never touched, even the places we cannot see. And it was a chilling preview of a darker secret, a larger truth that scientists are only now beginning to fully confront. This deepest of trenches, this ancient, isolated abyss, may in fact be the planet's final, darkest, and most hidden garbage dump. Not just for plastic bags, but for everything we have thrown away and tried to forget. So, how did this place come to be? This abyss that now reflects our own carelessness back at us? What is it, geologically, this scar on the face of the planet? We call it a trench, but that word, that simple, familiar word, is a bit misleading. It suggests a ditch that was dug, a crack that split open, a furrow ploughed by some giant hand. The truth is far slower, far more powerful, and far more strange. The Mariana Trench is the direct result of a collision. Not a fast collision, not a dramatic impact, but a slow, grinding, relentless, million-year-long collision. It is a place where the Earth is actively, at this very moment, recycling itself, eating its own skin and growing new skin in an endless, patient cycle. It is formed by two of the planet's massive tectonic plates. The Pacific Plate, vast, ancient, covering most of the Pacific Ocean floor, and the Philippine Plate, smaller, younger, but equally unyielding. For millions of years, the Pacific Plate has been crawling across the ocean floor, moving at about the same speed that your fingernails grow, a few centimeters a year, driven by forces deep within the Earth's mantle. And for just as long, it has been crashing into the Philippine Plate. In this colossal, slow-motion impact, the Pacific Plate, being older, denser, and colder, is the one that gives way. It does not stop. It cannot stop. It is pushed by the momentum of an entire ocean basin. So it is forced to dive, to bend, to scrape and grind its way under the edge of the Philippine Plate. This process is called subduction. The word comes from the Latin for to lead under. The Pacific Plate is subducting, leading itself under the Philippine Plate, descending into the hot, molten mantle of the Earth. But what is hard, almost impossible, to truly imagine is the scale. This is not a clean or simple event. It is not like one card sliding under another. It is a grinding, tearing, splintering, fracturing of the entire crust of the Earth. Imagine the worst earthquake you have ever felt, multiplied by 1,000,000, happening every second for millions of years. That is subduction. As the Pacific Plate is forced down into the Earth's hot mantle, it does not go quietly. It drags the edge of the overlying plate, the Philippine Plate, down with it, creating that deep, V-shaped scar on the ocean floor. The trench is the surface expression of this deep, hidden violence. It is the bend, the fold, the place where the Earth's skin wrinkles and sinks. The process is impossibly slow by human standards. The plates move at that fingernail-growing pace, a few centimeters a year. But over the span of geological time, over tens of millions of years, that slow, relentless, unstoppable movement has carved a chasm deeper than Mount Everest is tall. If you could take Mount Everest, the highest mountain on Earth, and drop it into the Mariana Trench, its summit would still be over a mile beneath the surface. That is the scale of this abyss. That is the depth of this scar. So when we look at the trench, when we try to comprehend it, we are not looking at a static feature, a finished product, a hole that was dug and then left alone. We are looking at a live, ongoing, active geological event of immense, almost unimaginable power. A process that is happening right now as you listen to these words. The Pacific Plate is still diving. The trench is still deepening. The collision continues,
And this grinding, constant, unstoppable movement is not a smooth or quiet affair. It is not a gentle glide. It is an engine for some of the planet's most dramatic, most destructive, most violent events. The very same forces that carve the trench are the forces that shake our cities and flood our coastlines. That grinding, swallowing motion of one plate diving beneath another is not a smooth, frictionless process. It is a messy, violent, and chaotic affair. As the Pacific plate is forced down into the mantle, it does not just slide, it scrapes, it bends, it catches, and in some places, along some sections of the fault, it gets stuck. For decades, or even for centuries, a particular section of the plate will lock in place. The rocks, under immense pressure, will hold. They will resist the movement that the rest of the plate is undergoing.
But the rest of the plate, the unstoppable mass of a continent-sized slab of rock, keeps pushing. It does not stop. It cannot stop. The tension builds. An incredible, almost incomprehensible amount of stress accumulates in the rock, miles and miles below the seabed, deep in the cold, brittle crust. It builds, and builds, and builds, for years, for decades, for centuries. The rock bends. It warps. It stores energy like a spring being slowly, inexorably compressed, until finally, after all that time, after all that tension, the rock can no longer hold. It reaches its breaking point. It ruptures. In that single, instantaneous, catastrophic moment, all that stored energy, all those centuries of accumulated stress, is released in a single, violent jolt. An earthquake. The ground shakes. The seabed lurches. The energy radiates outward, through the rock, through the water, for thousands of miles. But these are not the earthquakes we are used to feeling on the surface. They are not the shallow, sharp shudders that knock things off shelves and crack foundations. The Mariana Trench is a subduction zone, and subduction zones give birth to some of the most powerful, and by far the very deepest, earthquakes on the entire planet. Most earthquakes happen in the top 50 kilometers of the Earth's crust. That is where the rock is cold and brittle, where it can break. In the Mariana Trench, earthquakes are recorded happening hundreds of kilometers down, 300, 400, even 600 kilometers beneath the surface. This is a profound geological puzzle, a mystery that still puzzles seismologists. At that depth, the heat and pressure are so immense, so extreme, that rock should not be brittle. It should not be able to break. It should bend, flow, deform like putty or warm taffy. It should not snap, and yet it does. It shatters. Deep within the earth, in a realm we thought was too hot and too pressurized for brittle failure, the rock breaks. We are recording tremors, earthquakes, from a place we thought was geologically incapable of producing them. These deep tremors are too far down for us to feel them directly on the surface. They are muffled, dampened by the miles of rock above them. But they are often the trigger, the match that lights the fuse for something far more dangerous. When that deep tension releases, it can transfer its massive energy upward like a whip cracking. It can cause the entire overlying plate, the plate we live on, the plate that forms the seabed, to lurch violently. When that happens, when a massive section of the seafloor suddenly shifts, sometimes by meters or even tens of meters, it acts like a giant, planet-sized paddle. It displaces a column of water miles high, pushing the entire ocean above it. That displaced water becomes a wave, but not a normal wave. A wave that travels at the speed of a jet aircraft across entire ocean basins, growing taller as it approaches shallow water. A tsunami. The trench, it seems, this quiet, hidden abyss, is a quiet, hidden engine for change on a massive, planetary scale. It is the birthplace of some of the most powerful forces on Earth. And it does all of this in silence, in darkness, miles beneath our feet, while we go about our daily lives, unaware. But that violent, tectonic shifting, that grinding of plates and cracking of deep rock, is not the only way the Earth's deep energy escapes from the trench. It also leaks, in a slower, quieter, stranger way. When we think of ocean vents, of the places where the Earth's interior meets the sea, we usually picture fire. We imagine the black smokers, the dramatic, billowing plumes of superheated, mineral-rich water seen in almost every deep-sea documentary. The images are iconic. A towering chimney of black rock pouring out a thick, dark, smoke-like fluid into the cold, clear water. Fire and ice, heat and cold. The interior of the earth meeting the ocean. The trench has those. But it also has something else. Something stranger. Something that seems to follow a different set of rules, a different kind of chemistry. Near the Ahi volcano, a submerged, active volcano within the Mariana Trench system, scientists discovered a field of hydrothermal vents. As their robotic submarines approached, they saw the familiar chimneys, the structures built up by mineral deposits over centuries. They saw fluid venting from the cracks in the rock. But there was no black smoke. There was no dramatic plume. There was no fire. Instead, rising from the cracks in the rock, shimmering in the light of the submarine's lamps, were pearlescent bubbles. Not dark, not smoky, but translucent, glowing, like liquid pearls rising slowly through the dark water. They were venting almost pure liquid carbon dioxide. On the Earth's surface, at the air pressure we live in, carbon dioxide is a gas. It is invisible, odorless, the thing we exhale with every breath. To make carbon dioxide a liquid, to force it into that state, you need extreme pressure and very low temperature. You need conditions that do not exist naturally on the surface of our planet. The trench, it turns out, with its crushing pressure and near-freezing temperatures, provides those conditions perfectly. It is the only known place on Earth where liquid carbon dioxide occurs naturally, venting from the Earth's mantle into the ocean. The scientists who discovered it named it, appropriately, the Champagne Vent. And the view, as captured by the submarine's cameras, is surreal. It is a slow, cold, steady stream of liquid gas bubbling up from the planet's interior, rising like the fizz in a glass of champagne, only in slow motion, only in the crushing dark, only 7 miles beneath the surface. It is a glimpse into a truly alien chemistry. A world where the rules are so different, so inverted, that a gas we exhale, a waste product of our own bodies, becomes a shimmering, bubbling liquid flowing from the rock. This cold, strange, beautiful place is a reminder that the trench is not just a physical location, a hole in the ground. It is a chemical one. The pressure doesn't just crush, it creates. It forges conditions and materials that cannot exist anywhere else on the surface of our planet. But not far from this cold, strange anomaly, its fiery twin does exist. A place where the trench stops leaking, stops bubbling, and starts instead to boil. These are the more famous, more dramatic, more studied hydrothermal vents known as black smokers. In these zones, the ocean floor is thin. The crust is stretched and fractured by the tectonic forces pulling it apart. Seawater seeps down through these cracks, these fissures, traveling miles deep into the Earth's crust until it gets close to the magma, the molten, superheated rock of the mantle. There, deep beneath the seabed, the water is superheated to an almost unbelievable degree. Over 400 degrees Celsius. Over 750 degrees Fahrenheit. That is hot enough to melt lead, hot enough to melt zinc, hot enough to turn most metals into liquid. But at this depth, under this immense pressure, the water cannot boil. It cannot turn into steam. The pressure is too great. The water is forced to remain liquid, even at temperatures far above its normal boiling point. It becomes a pressurized, acidic, superheated fluid, a liquid so hot and so corrosive that it seems almost magical. This superheated fluid dissolves the rock around it. It leaches minerals out of the solid basalt, becoming a thick, toxic, mineral-rich soup. A broth of sulfur, iron, copper, zinc, lead, and a dozen other elements, all dissolved, all suspended, all carried in this impossibly hot, impossibly pressurized water. And then, eventually, it finds a way out. It follows the cracks back up, towards the surface. It shoots back up into the ocean, blasting out of chimney-like structures on the seabed, structures it has built itself over centuries of deposition. The moment this 400-degree, acidic, mineral-laden fluid hits the near-freezing, chemically neutral ambient water of the trench, the dissolved minerals cannot stay dissolved. They instantly solidify. They precipitate out of the solution, forming a cloud of fine, dark, particulate matter that looks exactly, precisely, like thick, billowing black smoke. Black smoke rising from a chimney on the bottom of the ocean. It is one of the most raw, most direct, most elemental scenes on the entire planet.
a place where the superheated, violent interior of the Earth meets the cold, crushing, dark deep of the ocean. A place where two opposite extremes collide, and in that collision create something new. For decades, for most of the 20th century, we assumed these places were sterile. We assumed that nothing could possibly live there. What could survive a blast of acidic water hot enough to melt lead? What could live in a darkness poisoned with sulfur and heavy metals? What could thrive in a place that seemed more like a chemical factory than a habitat? We believed that all life on Earth ultimately, directly or indirectly, drew its energy from the sun. Photosynthesis was the foundation. Plants captured sunlight, and everything else ate the plants, or ate something that ate the plants. The sun was the source. But when our robots, our remotely operated vehicles, finally reached these black smokers, when our cameras peered through the dark water and the billowing smoke, we found them teeming, swarming, absolutely covered with life. They found forests of pale, giant tube worms, 6 feet long, with no mouth and no stomach, with no digestive system at all, feeding entirely on chemicals. They found fields of ghostly white crabs, blind, scuttling over the hot chimneys, grazing on the bacteria that grew there. They found shrimp clustered so densely, so thickly, that they seemed to be boiling in the shimmering, hot water. They found eels, octopuses, anemones, and hundreds of species that had never been seen before, that had no names, that did not fit into any known category of life. This discovery was a shock, a profound, paradigm-shifting shock. Here, in this toxic, superheated, sunless, lightless environment, was life that did not need the sun. It did not rely on photosynthesis. It was a new biology.
A new way of being alive. It was thriving on chemosynthesis, using the energy stored in chemical bonds, in hydrogen sulfide, in methane, in the raw, hot, mineral-rich fluid of the Earth itself. The creatures here were not eating each other's leftovers from the surface. They were not waiting for marine snow to drift down from above. They were creating their own energy, from scratch, from the heat and chemicals of the planet's interior. They were a completely independent ecosystem, a separate tree of life, a second playbook for how to be alive on Earth. That discovery of chemosynthesis, of life without sunlight, did more than just reveal a new ecosystem in a remote corner of the ocean. It threw a shadow of doubt, a long, dark, questioning shadow over our most fundamental story about ourselves, the story of the origin of life itself. For generations, for over a century, the favored theory of our creation, of the first spark of life on Earth, was a gentle one. We called it the primordial soup. We imagined, in the romantic language of early biology, life beginning in a warm little pond. As Charles Darwin himself famously wrote in a letter to a friend, life may have started in a warm little pond, with all sorts of ammonia and phosphoric salts, lights, heat, electricity, etc. present, so that a protein compound was chemically formed ready to undergo still more complex changes. It was a beautiful image, a shallow pool on the Earth's surface, bathed in sunlight, warmed by the young sun, struck by lightning, where simple chemicals slowly, over eons, assembled themselves into the first fragile, living cell. It was a story born of light and air, a story of gentle accumulation, a story that felt right, felt natural, felt almost hopeful. But the black smokers, these violent, superheated, chemical furnaces in the absolute dark of the abyss, offered a new, far harsher, far more violent, and perhaps far more plausible alternative. A story born of fire and pressure. A story of violence and chemistry. A story that feels less hopeful, perhaps, but more grounded in the reality of the early Earth. This is the hydrothermal vent hypothesis. The theory argues that these vents, these black smokers on the ocean floor, are the perfect, self-contained, natural laboratories for creating life. They have all the necessary ingredients. They have water, the universal solvent. They have extreme heat, which acts as the engine for chemical reactions, providing the energy that lightning might have provided on the surface. And most importantly, they have a powerful, persistent, natural gradient. On one side of the porous chimney wall, you have the superheated, acidic, mineral-rich fluid from the Earth's core. On the other side, you have the cold, slightly alkaline, mineral-poor water of the deep ocean. Where these two meet, in the microscopic, porous cracks of the chimney rock, a powerful chemical energy is unleashed. It is like a natural battery.
a perpetual source of energy that does not depend on the sun, that does not depend on lightning, that does not depend on chance. It is constant. It is reliable. It has been there for billions of years. This is a place where hydrogen and methane, the simplest organic molecules, the building blocks of life, are abundant. This is a place where tiny, iron sulfide pores in the rock, microscopic cavities, could have acted as the first cells.
They could have concentrated these chemicals, protected them from the environment, and allowed them to organize, to react, to begin the slow, stumbling process of becoming alive. It is a compelling idea. A powerful idea. Life may not have started gently in the sun. It may not have begun in a warm little pond. It may have been forged in the dark, in the crushing pressure, in the toxic, superheated water of a hydrothermal vent. It may have been born in a place that looks, to our eyes, like hell. If this theory is true, if the evidence continues to support it, it means the trench is not just a strange biological sideshow, a curiosity at the bottom of the world. It could be our home, the shared, dark, chemical-rich birthplace for every living thing on Earth. The first cell, the common ancestor of all life, may have drawn its first breath not from the air, but from the hot, mineral soup of a black smoker. And it also suggests something profound, something important about the universe. If life can begin here, on Earth, in total darkness, without any sunlight at all, then perhaps the sun is not a requirement for life anywhere. Perhaps the universe is far more full of life than we ever imagined. Perhaps every icy moon, every dark exoplanet, every cold, pressurized ocean in the galaxy is a potential cradle. To find these strange life forms, these chemosynthetic creatures that rewrite our understanding of biology, however, you must enter a realm that is almost mythological. A realm that had a name before we ever visited it, a name that seems to predict the dread and wonder we feel when we think of it. Scientists divide the ocean into zones based on light. The sunlight zone, the epipelagic, from the surface down to about 200 meters, where there is enough light for photosynthesis. The twilight zone, the mesopelagic, from 200 to 1,000 meters, where light fades to a dim, blue glow and then to nothing. The midnight zone, the bathypelagic, from 1,000 to 4,000 meters, where no light from the surface has ever reached. But below that, below 4,000 meters, below the midnight zone, you enter a place so deep, so extreme, so fundamentally different that it was given its own separate classification. It is called the hadal zone, and it is named, appropriately, hauntingly, after Hades, the ancient Greek god of the underworld, the realm of the dead, the place that lies beneath the world of the living. The hadal zone is not just a deeper, darker version of the ocean. It is a fundamental shift in the rules of biology. It is a threshold, a place where life as we know it, life as it exists on the surface, was thought to be impossible. The defining feature, the absolute barrier, is the pressure, which at this depth, below 6,000 meters, stops being a simple physical force, a weight that crushes, and becomes something else entirely. It becomes a biochemical one. It becomes a force that attacks the very building blocks of life. The extreme pressure of the hadal zone actively invades the membranes of cells. It squeezes the fatty molecules that form cell walls, making them rigid, unworkable, unable to function. It contorts the very shape of proteins, the molecular machines that do all the work in our cells, twisting them out of their precise, folded shapes, stopping them from latching onto other molecules, stopping them from doing their jobs. It essentially halts the engine of metabolism as we know it. It stops the chemical reactions that are life. For a complex animal from the surface, a fish or a crab or a human, a descent into the hadal zone would mean death. But not the death we imagine. Not death from being crushed, from the hull failing, from the body collapsing. A slower, stranger death. A systems failure. The nervous system would fail. The proteins would unwind. The cell membranes would lose their integrity. The signals would stop firing. The body would simply, quietly, cease to function. Not because it was torn apart, but because its chemistry stopped working. This is why, for the longest time, for most of the 20th century, we believed the hadal zone was sterile. We believed it was a biological forbidden zone, a place where life could not take hold, a dead zone at the bottom of the world. It was a logical conclusion. It fit the data we had. The pressure was simply too great. But life, it turns out, is more stubborn, more inventive, more resilient than our theories. Life did not just visit the hadal zone, it did not just survive there, it adapted. It rebuilt itself from the ground up, from the molecular level, to see this impossible, crushing pressure not as a hostile, destructive force, but as a normal, necessary, even beneficial part of its existence. The creatures that live in the hadal zone are biochemical marvels. They have solved problems we are only just beginning to understand. They have rewritten the rules of biology to fit their extreme environment. They are, in a very real sense, aliens. Aliens that share our planet, that evolved from the same common ancestor, but that have gone down a completely different path, a path we are only now beginning to map. So what then is the master of this hadal underworld? What kind of creature would you expect to be the apex predator, the top of the food chain, the king of the abyss in a realm of 1,100 atmospheres of pressure? Our imagination, conditioned by a lifetime of movies and monsters and myths, pictures a leviathan, something armored with a thick shell and a dense skeleton, a creature built like a tank, like a submarine, with reinforced armor to resist the crushing weight, something ancient and powerful, with big teeth and a bigger appetite. The reality, discovered only a few years ago, is the complete opposite. And it is far more strange. The most successful predator in the deepest part of the Mariana Trench, the creature that has adapted most perfectly to this extreme environment, is a fish. A small, unassuming, almost fragile-looking fish. It is called the Mariana snailfish. And it is a ghost. It is about the length of your hand, perhaps 6 or 7 inches long. It has no scales, no armor, no thick skin. Its skin is a translucent, pale pink, almost completely transparent. You can look through its skin and see its organs functioning inside. You can see its heart beating. You can see the food moving through its gut. It is a living window. Its skeleton is not hard, calcified bone, the way our skeletons are, the way most fish skeletons are. It is made mostly of flexible cartilage, like the cartilage in your nose or your ears, but even softer. It is fragile. It is soft. It is almost gelatinous to the touch. If you could hold one, which you cannot, it would feel like a soft, wet, wobbly bag of jelly. And it is the king of the abyss, the top predator, the most successful vertebrate in the deepest, most extreme environment on Earth. This creature is the ultimate example of hadal biology. It is the proof that in the trench, the rules are inverted. It does not fight the pressure. It does not resist it. It has joined it. It has embraced it. It has made the pressure part of its biology. The snailfish's body is a marvel of adaptation, a lesson in how life can solve impossible problems. To survive, it did not build walls. It did not thicken its skin or reinforce its bones. It opened the gates. It let the pressure in. Its cells are filled with special molecules, organic compounds called piezolites. The name means pressure salutes. These molecules literally hold the cell's proteins and membranes together. They prevent the proteins from unfolding, prevent the membranes from becoming rigid, prevent the cell's machinery from failing. They act like molecular glue, strengthening the weak points, protecting the delicate chemistry of life from the crushing force of the environment. Its body, because of these adaptations, is in essence a gel. It is not a rigid, solid structure. It is a soft, flexible, fluid-filled bag of cells. And because it is soft, because it is flexible, because it does not have air pockets or rigid bones, it has achieved a perfect, delicate, almost miraculous equilibrium with the 16,000 pounds per square inch of force pressing in on it from all sides. Inside and outside, the pressure is balanced. The fish is not crushed because there is nothing to crush. It has become one with the abyss. This is also why it is a phantom, a ghost that can only exist in its specific, narrow depth range. This fish can only live at that depth, under that specific pressure. If you were to bring a Mariana snailfish to the surface, to the comfortable, low-pressure world we live in, it would not explode. That is what our imagination pictures. A fish from the deep, brought up too fast, expanding like a balloon and popping. It would do the opposite. It would melt.
Without the immense pressure holding it together, without the external force that its cells are built to require, its very structure, the cells and proteins that were evolved to be supported by that weight, would simply fall apart. The piezolites would stop working. The proteins would unfold. The membranes would lose their integrity. The fish would dissolve. It would collapse into a gelatinous, formless slurry of organic molecules, a puddle of what used to be a snailfish. It is a creature that cannot leave its prison, because that prison, that crushing, impossible pressure, is also its life support. It is an animal built of pressure, a soft, translucent, gelatinous hunter that glides through a world that would vaporize us, that would pulverize our bones and collapse our lungs, as if it were nothing, as if it were home. The snailfish is not alone in its ghostly, transparent appearance. It is not an exception. In the hadal zone and in the deep midnight zone just above it, evolution seems to have arrived at the same strange, counterintuitive conclusion over and over again. If you cannot fight the environment, join it. If you cannot survive the pressure, become part of it. And if you cannot hide from predators in the open water, where there are no caves, no rocks, no shadows, then you must simply disappear. In a world of total, absolute darkness, there are no shadows. There are no dark corners to hide in. There are no caves or forests or kelp beds. It is just open, endless, featureless water stretching in every direction.
The only way to truly hide, to avoid being eaten, is to not be seen at all. And the best camouflage, the most effective disguise in a world with no light to create shadows, is to become invisible, to become transparent, to become glass. And so, the deep is filled with creatures that are essentially made of glass. Living windows floating through the eternal dark. One of the most spectral, most beautiful, most unsettling of these is the telescope octopus. It is almost entirely transparent. Its body is a gelatinous, slow-moving, bell-shaped form like a jellyfish. But it is an octopus, a relative of the clever, curious creatures of the shallows. Its body is so clear, so perfectly see-through, that the only things you can really see, the only opaque parts, are its digestive tract, glowing faintly with the remains of its last meal, and its two enormous, stalk-like eyes. These eyes are what give it its name. They are tubular, like binoculars or telescopes, pointing upwards, not sideways. And they can rotate. The octopus can swivel these stalked eyes to look in different directions, scanning the darkness above. Because in the deep, the most important direction is up. Up is where the faint, dim light comes from. Up is where the silhouettes of prey appear against the distant, barely their glow of the surface. Up is where danger comes from. So the telescope octopus spends its life staring upwards, watching, waiting, its transparent body invisible to anything looking from below. Then there is the glass squid, a creature so fragile, so delicate, it seems impossible that it could survive in any environment. Its body is a perfectly clear, perfectly transparent, fragile balloon. It hangs in the water, almost motionless, its tentacles trailing below it, undetectable, invisible. But this creates a problem. Its eyes, which it needs to see, are opaque. Its digestive gland, which it needs to digest its food, is opaque. These small, dark, solid parts would cast a shadow if a predator's light were to hit them. A shadow in the deep is a death sentence. It is a signal. It says, "Here I am, eat me." The glass squid, however, evolved an ingenious, almost technological solution. It uses its own internal light, its bioluminescence, not as a beacon to attract prey, but as camouflage, as counter-illumination. It produces just enough light from photophores on its underside to match the faint, ambient glow from the surface above. It erases its own shadow. It fills in the dark spot that its body would otherwise cast. It becomes, for all practical purposes, perfectly invisible from below. A living invisibility cloak. A creature that has solved the problem of being seen by becoming its own light source. These creatures, the telescope octopus, the glass squid, the transparent jellyfish, the ghostly ctenophores, are the phantoms of the abyss. They have engineered themselves, through millions of years of evolution, out of existence. They have become living windows. Fragile, beautiful, impossible beings that float through the darkness,
proving that in this extreme, crushing, lightless world, the best defense is not armor, not speed, not poison. It is absence. It is the art of not being there at all. To become invisible, to erase yourself from the visual field, is one powerful strategy in this permanent, ancient night. But there is another, more active, more aggressive, and perhaps more counterintuitive solution. If you cannot disappear, if you cannot become transparent, you must do the opposite. You must control the dark. You must become the source of light. You must make your own.
This is the world of bioluminescence, the world of living light. In the deep ocean, light is not a gentle, ambient presence the way it is on the surface. It is a tool, a weapon, a lure, a language. And because it is so rare, because the darkness is so absolute, a single point of light is incredibly, disproportionately powerful. It is a signal that cuts through the void. It is a beacon that can be seen for miles in the clear, dark water. And it is a language, a lure, and a weapon, all in one. The most famous master of bioluminescence, the creature that has become the icon of the deep, is, of course, the anglerfish. It is a creature that seems perfectly, almost artistically, designed for an environment of absolute scarcity. An environment where every calorie must be hoarded, where every movement must be efficient, where wasting energy is death. The anglerfish is, in essence, a vast mouth with a built-in fishing rod. Its body is globular, dark, and almost formless. It has no scales, no fins worth mentioning, no streamlined shape. It is a sack with teeth. And those teeth are needle-sharp, translucent, and curved inward like the bars of a cage. Once something enters that mouth, there is no escape. The teeth form a trap that cannot be opened from the inside. But its true genius, its evolutionary masterpiece, is its efficiency. The anglerfish cannot afford to waste energy chasing prey through this vast, empty blackness. There is no point in swimming, in hunting, in pursuit. The chance of encountering food is too low, and the cost of movement is too high. So it does not hunt. It waits. It hangs motionless in the water, barely moving, its metabolism slowed to a crawl, conserving every possible calorie. And from its head, just above that enormous mouth, sprouts a long, fleshy filament, a rod, a fishing pole made of flesh. At the end of that filament is a small, glowing, fleshy bulb called an esker. And this light is not the fish's own. It is not produced by the anglerfish's body. It is a living, symbiotic colony of bioluminescent bacteria glowing faithfully in the dark, fed and protected by the fish that hosts them. The fish provides the bacteria with a safe, nutrient-rich home, and in return, the bacteria provide the fish with a constant, hypnotic, irresistible lure. A single, pale, blue-green light pulsing gently in the absolute blackness. A smaller fish or crustacean, navigating the dark, perhaps hungry, perhaps curious, sees this light. It is the only point of interest in a featureless, empty world. It is the only thing that stands out. Perhaps it looks like a potential meal, a smaller bioluminescent organism, something to eat. Or perhaps it is just a mystery, and curiosity is a powerful driver, even for a fish. They drift closer. The anglerfish, sensing the movement through its lateral line, through the vibrations in the water, does nothing. It waits. It is patient. It has all the time in the world. Closer, closer still, until the prey is directly in front of that enormous mouth. And then, with a sudden, explosive snap of its jaws, a movement so fast it is almost invisible, the world ends for that small creature. The hunter has captured its meal using almost zero energy. It has turned the darkness into an ally. It has made light a trap. Other creatures are more aggressive, more active hunters. The dragonfish, for example, is a long, black, eel-like creature, sleek and muscular, with fangs so large, so disproportionately long, that it cannot even close its mouth. Its teeth are like needles, designed to impale and hold, not to chew. It too uses glowing lures on its body, photophores arranged in patterns along its underside to attract prey. But it also has a secret weapon. A piece of biological engineering that is almost unbelievable, almost like science fiction. The dragonfish has evolved a pair of searchlights. 2 glowing organs, photophores, located just beneath its eyes. And these searchlights do not glow with the common blue or green of most bioluminescence. They glow with a deep, far red light, a color that almost no other creature in the deep ocean can see. This is a revolutionary advantage, a biological cheat code. In the deep ocean, the only light that penetrates from the surface, the only ambient light that exists, is blue. Blue light travels farthest through water. As a result, almost every creature in the deep has evolved to see only the blue part of the spectrum. Their eyes are tuned to blue. They are, for all practical purposes, completely, utterly blind to red light. Red light is invisible to them. It does not exist in their visual world. The dragonfish, however, is one of the very, very few creatures that can both produce and see this red light. It has a private, secret spectrum. It has developed a biological sniper scope, a pair of night vision goggles made of flesh and chemistry. It can swim through the darkness, shining its invisible red beams forward. The light illuminates everything in front of it, but only the dragonfish can see it. The prey, the small fish and shrimp, continue to swim in what they believe is total, absolute, safe darkness. They have no idea that they are being watched, no idea that they are glowing like beacons in a spectrum they cannot perceive. No idea that a predator is targeting them, following them, closing in with its own private, invisible spotlight. In this world, light is a complex and deadly game. It is a lure to draw prey in. It is a threat display to warn rivals away. It is a signal to find a mate in the endless dark. And for the dragonfish, it is a private, invisible spotlight, giving it the ultimate, unfair advantage in the permanent, ancient dark. The anglerfish and the dragonfish are the sophisticated hunters of the midwater. They play their complex games of light and shadow, of patience and ambush in that open, empty, three-dimensional blackness. They are the aces of the abyss. But on the seabed itself, on that vast, silty, flat plain at the very bottom of the trench, life takes on a different form, a slower form, a more methodical, patient, almost meditative form. It is a world of sifters and grazers, of creatures that do not chase or lure, but simply wait for the snow to fall. When researchers first sent cameras, high-definition video cameras in pressure-resistant housings, down to the floor of the Challenger Deep, they saw them scattered everywhere in the ooze. At first, they did not look like much. They looked like small, delicate, flat sponges, or perhaps like discarded, crumpled paper. Some resembled pale, lumpy, discarded brains, wrinkled and folded. Others had built intricate, beautiful, flower-like or root-like structures branching out across the mud. But they are not sponges, they are not plants, they are not coral, they are not colonies of tiny animals working together. They are xenophyophores, and they represent one of the greatest, most mind-bending paradoxes of the abyss. The reason they are a paradox, the reason they challenge our fundamental understanding of what life can be, is their structure. That entire complex, branching, sometimes beautiful, sometimes ugly organism, sometimes as large as your fist, or a dinner plate, or even larger, is not a colony of thousands of individual cells working together. It is not a multicellular organism. It is a single cell. One cell, one nucleus, one bag of protoplasm. These are, by a vast, astonishing margin, the largest single-celled organisms on Earth. They are, in essence, giant amoebas. They have no organs, no nervous system, no brain, no muscles, no cooperation between specialized parts. It is just one enormous, sprawling, branching bag of living material, a single cell the size of your hand. They are the simplest form of animal-like life, the most basic level of complexity, scaled up to giant proportions. And they have chosen, for reasons we do not fully understand, the most complex, most extreme, most hostile environment on Earth as their home. Why? How? They survive by doing almost nothing, by moving incredibly slowly at the pace of growing grass across the surface of the mud. They absorb nutrients directly from the silt, filtering the marine snow that has fallen all this way, pulling organic particles out of the sediment. They are, in effect, living vacuums. But their true genius, if you can call the blind, unthinking product of evolution genius, is in their architecture. To protect their single, fragile, enormous cell from the harsh environment, from predators, from the abrasive sediment, they build a complex, branching shell around themselves. A protective house made of the materials of the deep. But they do not grow this shell the way a snail grows its shell from their own body. They are not masons building with bricks they have made. They are collectors. They are microscopic, single-celled architects. They sift through the ooze, carefully, slowly, selecting specific materials from the sediment. Grains of sand, the tiny, beautiful, intricate shells of other dead organisms, of foraminifera and radiolarians. Mineral flakes, pieces of sponge spicules. And they glue these materials together using a kind of biological cement, a sticky, organic glue that they secrete from their single cell. The structures they build, called tests, are astonishingly intricate. They are not solid, heavy walls. They are lightweight, porous, and strong lattices, like a coral reef made of collected debris. This structure gives them a massive surface area, allowing them to absorb as much of the sparse nutrients from the water and sediment as possible. It also gives them a protected, stable shape, preventing their single, fragile cell from collapsing or tearing. The trench, the deepest, darkest, most extreme place on Earth, is full of them. They are everywhere on that pale, silty floor. They are a fundamental, foundational part of the ecosystem, creating the first level of structure, the first complexity, on an otherwise flat, barren, featureless mud plain. They are the architects of the abyss, and they are a strange, humbling lesson in evolution, in a place defined by crushing pressure, a place that makes it almost impossible for complex, multicellular life to build hard skeletons of calcium. The most successful, most abundant, and largest creatures on the very bottom are the simplest of all. The humble amoeba. The single cell. The creature with no brain, no organs, no ambition, has inherited the deepest dark. It is a reminder that in the trench, the rules are not just different, they are often inverted. Complexity is not always an advantage. Sometimes the oldest, simplest, most patient strategy wins. The giant amoeba, the xenophyophore, is a marvel of minimalism. It succeeded by becoming large without becoming complex.
But it is not the only creature that has achieved an unusual, unsettling size in the deep. Another creature, a much more familiar kind of creature, took a different path. It followed a strange, poorly understood, and deeply unsettling rule of the deep ocean. A phenomenon that still puzzles marine biologists. They call it deep-sea gigantism. This is a rule that takes the small, the familiar, the everyday, and scales it up. It takes creatures we know from the shallows, from tide pools, from beaches, from the surface world, and it magnifies them. It stretches them. It turns them into giants. But not giants of the dramatic, monstrous, science fiction kind. Giants of the slow, pale, patient kind. All over the world's oceans, in shallow water, in tide pools, on sandy beaches, there is a tiny, common crustacean called an amphipod. You have probably seen them, though you may not have known their name. They are sand hoppers, beach fleas, freshwater shrimp. Small, scurrying, hopping creatures, rarely larger than your fingernail. They are everywhere. They are the insects of the ocean. In the grand, majestic scheme of the ocean, with its whales and its sharks and its giant squid, amphipods are insignificant. They are the background noise, the small fry. When scientists, curious about life in the deep, first sent baited traps down into the Mariana Trench, they were not sure what to expect. They were hoping for new species. Perhaps the ghostly snailfish they had heard rumors of. Perhaps strange, undiscovered crustaceans. Perhaps giant worms. They lowered the traps, waited, and pulled them back up. The traps were not empty. They were not disappointing. They were filled. Swarming, crawling, packed with amphipods. The traps had attracted a feeding frenzy of these small crustaceans, as they do in shallower water. But these were not the small, fingernail-sized amphipods from the surface. The creatures that crawled inside the traps, that swarmed over the bait, that filled the collection chambers, were pale, white, ghostly, and they were unusually, shockingly large. They were the size of a human hand, Some individuals, measured carefully in the shipboard laboratory, were over 20 centimeters long. The largest, captured in a different trench, the Kermadec Trench near New Zealand, was over 34 centimeters long, the size of an adult's shoe, a crustacean that is normally a millimeter or two long, scaled up to the size of a small lobster. This is the supergiant amphipod Alyssella gigantea. It is, in every way that matters, the same humble, simple, insignificant creature from the shallows. The same body plan, the same legs, the same antennae, the same simple eyes. But in the trench, under the pressure, in the cold, it has been magnified. It has been stretched. It is as if a common house spider, the tiny thing you find in the corner of your bathroom, grew to the size of a dinner plate. It is the familiar made strange, the small made large. This discovery, made only in the last few decades, was a biological shock, a puzzle. Deep sea gigantism had been observed before, in other groups, but never so dramatically, never so extremely. Why does this happen? Why does the deep, with its scarcity and its pressure, produce giants? The theories are still just theories. They are debated in scientific papers and at conferences, but they offer a fascinating, speculative glimpse into a different kind of life. A life governed by different rules, a different pace, a different logic. One idea, perhaps the simplest, is that the extreme cold of the deep water, combined with the immense pressure, slows down a creature's metabolism to an almost glacial pace. These creatures don't grow faster than their surface cousins.
In fact, they grow much, much slower. They just live longer, much longer. And perhaps, in the deep, they never receive the biological signal to stop growing. They just keep going, year after year, decade after decade, century after century, adding a little bit of size each time they molt. In the warm, fast-paced, high-predation surface world, life is short. You grow fast, reproduce, and die before something eats you. In the deep, it is slow and long. There are fewer predators. There is less competition. You can take your time. You can grow old. You can grow large. Another theory ties into the scarcity of food. Gigantism, in this view, is not an accident. It is an adaptation, an advantage. A larger body is a better storage unit. It can hold more fat, more reserves, more energy. In a food desert, where meals are few and far between, a larger animal can survive longer between feedings. It can gorge itself when a rare large meal does arrive, like a whale fall, and then live off those stores for months, or perhaps even years, while waiting for the next feast. The small, fast metabolism creatures would starve. The large, slow, patient ones would endure. Whatever the reason, whatever the evolutionary driver, the supergiant amphipod is one of the most striking, most unsettling residents of the trench. It is not an alien monster from a bygone age. It is not a myth or a legend. It is something we know, something familiar. A common, everyday, humble creature twisted by the darkness, the cold, and the pressure into a pale, armored, patient giant that swarms the deepest floor on Earth in numbers we are only beginning to count. So this entire strange, inverted, extreme ecosystem, this world of ghosts and giants, of glass creatures and living lights, of single-celled architects and patient predators, raises a fundamental, unavoidable question. What does it all run on? What is the fuel? What is the energy source that powers this kingdom of the dark? We have these apex predators like the snailfish, waiting in the gloom. We have these massive scavengers like the supergiant amphipods, swarming over any carrion that falls. We have the filter feeders, the sea cucumbers, the worms, sifting through the mud. But an ecosystem cannot be made of only predators and scavengers. There must be a foundation, a primary source of energy, a base of the food chain. On the surface of the Earth, that source is obvious, visible, overwhelming. It is the sun. It fuels the plants, the algae, the phytoplankton. They capture the sunlight and turn it into energy through photosynthesis. The herbivores eat the plants. The carnivores eat the herbivores. It is a short, energetic, and obvious chain, a chain that begins with a star. In the hadal zone, 7 miles down, there is no sun. There is no light at all. There are no plants, no algae, no phytoplankton.
The black smokers, the hydrothermal vents, are one answer. They provide a powerful, localized chemical energy source. They support their own unique chemosynthetic ecosystems, the tube worms and the blind crabs. But these vents are rare. They are tiny, isolated oases of life in a vast, cold, silent desert of mud that stretches for thousands of kilometers in every direction. They cannot be the only answer. They cannot be what fuels the snailfish and the giant amoebas and the supergiant amphipods out on the cold, flat, featureless plains of the abyssal floor.
The true fuel of the abyss, the real, constant, universal energy source that powers almost everything in the deep, is something far simpler, far quieter, far more constant, and far more humble. It is a slow, endless, gentle, almost invisible rain of organic matter drifting down, particle by particle, from the sunlit world miles and miles above. Scientists call it marine snow, and the name is perfect. It is a blizzard, but not a blizzard of ice and frozen water. It is a blizzard of the remnants of life and death. It is composed of the microscopic, glassy shells of dead plankton, the tiny algae and animals that live in the sunlit surface waters. It is fish scales, shed and drifting down. It is fecal pellets, the waste products of the countless creatures of the midwater. It is dust. It is bits of dead skin. It is the decayed, fragmented, broken down bodies of every surface creature that has died, that has been eaten, that has shed a part of itself, and has begun its long, slow, inevitable fall towards the bottom. This snow is the lifeline. It is the only connection, the only meager, tenuous thread between the bright, fast, energetic, productive world of the sun and the cold, dark, slow, patient world of the trench. It is the manna from heaven, falling not from the sky, but from the distant, invisible ceiling of the surface. But the journey is impossibly long. A single particle of marine snow, a fragment of a plankton shell, or a tiny fecal pellet can take weeks and sometimes months to complete its descent from the surface to the floor of the trench. It falls through the sunlight zone, the twilight zone, the midnight zone, the abyssal zone, and finally, the hadal zone. It falls for so long that the creature that produced it has long since died, been eaten, and been forgotten. And on that long, slow journey, it is picked apart, it is consumed. The creatures of the twilight zone, the lanternfish and the hatchetfish, get the first chance. They feed on the falling snow, intercepting it before it can fall deeper. Then the creatures of the midnight zone, the bristlemoths and the giant squid, take their share. Then the creatures of the abyss. An estimated 90% or even more of this marine snow is consumed, recycled and reconsumed by the inhabitants of the midwater and the deep before it ever reaches the hadal floor. What finally arrives at the bottom after all that time, all that distance, all that consumption is the last, most nutrient-poor, most degraded remnant. It is the leftover, the scrap, the crumb from a feast that happened miles above and weeks or months ago. It is a faint, constant, and barely nutritious dusting that settles slowly, gently on the pale, silty mud. And on this dusting, this crumb, this faint and barely adequate ration, almost everything in the deep depends. The giant amoebas, the xenophyophores, absorb it directly from the sediment. The amphipods sift the mud for it, spending their lives as living filters. The sea cucumbers, the holothurians, crawl across the plain, ingesting the mud, digesting the tiny organic particles, and excreting the cleaned sediment behind them. This is the base of the food chain. This is the foundation of the ecosystem. Life in the trench is not an economy of abundance. It is an economy built on starvation. A world of extreme, almost unimaginable patience, where creatures must wait for weeks, for months, for a single meal that has taken months to arrive. A world where the energy budget is so tight, so unforgiving, that every calorie must be hoarded, every movement must be calculated, every moment of activity must be justified. This is why life in the trench is so slow. This is why the snailfish is gelatinous and still. This is why the amphipods are pale and patient. This is why the giant amoebas do almost nothing. Their metabolisms are glacial. Their lives are measured not in days or weeks, but in years and decades. They are a world perpetually waiting for the snow to fall. a kingdom built entirely on the microscopic, degraded, almost invisible leftovers from a distant, unreachable heaven it will never, ever see. For decades, for most of the 20th century, we assumed this marine snow, this slow rain from above, was the entire system. It was the only story that made sense. We believed that all life in the deep mud, all the creatures of the hadal zone, were part of this simple, vertical, dependent chain. Wait for the snow. Eat the snow. Be eaten in turn. That was it. That was the abyss. But recent discoveries, made by drilling deep into the ocean floor, by sampling the sediment and the rock beneath the trench, have opened the door to a far more radical, far stranger, far more unsettling idea. What if there is another ecosystem down there? A separate, parallel biology? A world of life that does not rely on the surface world at all? A system that is completely, utterly independent of the sun? This is the theory of the shadow biosphere. It is not a theory of aliens from another planet. It is a theory of aliens from our own planet. A hidden, parallel biology living right beneath our feet, unknown and unseen. When scientists drilled into the sediment of the deep ocean floor, into the mud and the rock beneath the Mariana Trench, they found microbes. Tiny, single-celled organisms, bacteria and archaea. This in itself was not a shock. Microbes are everywhere, we know that. The shock was what these microbes were eating, where they were living. They were not clustered at the surface of the mud, waiting for the rain of marine snow. They were not dependent on the slow fall of organic particles from above. They were buried deep, deep within the sediment, meters down, tens of meters down, and even within the pores of the solid rock itself, the basalt of the ocean crust. And they were active, they were alive, they were metabolizing, they were growing, reproducing, living. But on what? What energy source fuels a microbe buried under meters of mud, sealed off from the surface, sealed off from the sun, sealed off from the rain of snow? They appear to be living on a diet of pure chemistry. Some of these deep subsurface microbes seem to be eating the rock itself. They are chemolithotrophs, rock eaters. They strip electrons from minerals, from iron, from sulfur, from manganese, using the chemical energy released by these reactions to power their cells. They are living, literally, on stone. But an even more fascinating, more speculative, more radical theory suggests they might be living on something else entirely. Something we usually think of as deadly, something we fear: radiation. We are now discovering microbes in deep subsurface environments, in abandoned mines, in nuclear waste sites that can survive and indeed thrive on radiation. They use the energy of radioactive decay, the natural, low-level radiation emitted by uranium, thorium, and potassium in the rocks, to split water molecules and produce energy. It is a process called radiolysis. The natural, low-level radioactive decay within the planet's rock and sediment is constant. It has been there for billions of years. It is a faint, weak, almost negligible source of energy. But it is constant. It is reliable. It never stops. And for a microbe that has slowed its entire metabolism down to an almost timeless state that lives on geological timescales, this faint, constant radioactive pulse might be enough. It might be a feast. This is a profound, almost unsettling speculation. If it is true, if there are microbes living on radiation deep beneath the ocean floor, it means there are creatures on Earth that live in a completely sealed system. They are not part of our sun-based food web. They are not connected to us, to the whales, to the plankton, to the marine snow, to the oxygen we breathe. They are a separate, parallel, hidden branch of the tree of life. Their timescale would be completely alien to us. A microbe living on the faint energy of radioactive decay might take 1,000 years to divide a single time. 1,000 years to become 2 cells. A human lifetime is a blink of an eye to such a creature. Its existence would be measured in geological epochs, not seconds or years. It would be a life form existing in a state that borders on geological time itself. Almost a different category of being. Are they the original, or at least a very ancient, form of life on Earth? Did life first evolve in these deep, dark, radiation-powered niches, hidden from the chaos and violence of the early surface? Or are they just an evolutionary curiosity, a weird side branch that has adapted to an extreme environment? We simply do not know yet. We have only just discovered that they might exist. But the possibility is fascinating, humbling, and profound. It suggests that when we look at the trench, when we study the hadal zone, we may not be looking at just one ecosystem. We could be looking at two worlds stacked on top of each other. One, the world we know, the visible world, living on the leftovers from the sun, on the slow rain of marine snow. And the other, a completely separate, hidden shadow world, living deep beneath the mud, in the pores of the rock, on the faint, slow, patient energy of the earth itself. So the ecosystem of the trench, this kingdom of the abyss, is defined by these two very slow, very patient, very strange economies. There is the steady, sparse, unpredictable rain of marine snow from above, which supports a life of extreme patience and extreme efficiency. And then there is that theoretical, radical, barely proven shadow biosphere deep beneath the mud, which may be living on a timescale of thousands of years, consuming rock and radiation, utterly independent of everything else on the planet. Both are lives of profound scarcity, lives of waiting, lives of endurance. Lives that have solved the problem of survival in the most hostile environment on Earth by simply slowing down, by becoming patient, by outlasting. But every once in a while, something happens that breaks all the rules of this starving, patient world. Something dramatic, something violent, something that delivers an unimaginable, almost unbelievable bounty to the abyssal floor. A single, massive, and completely unpredictable jackpot. It is called a whale fall. Imagine a 40-ton humpback whale or a 90-ton blue whale, the largest animal to have ever lived on Earth, dying in the sunlit world miles above. Perhaps it was old. Perhaps it was sick. Perhaps it was killed by a ship strike or a predator. Its massive body, too heavy to float, too heavy to be scavenged completely at the surface, begins the long, slow, final descent. It falls, spinning slowly, through the twilight zone, past the lanternfish and the hatchetfish. It falls past the midnight zone, past the bristlemouths and the giant squid. It falls for days, perhaps weeks, a mountain of flesh and bone and fat and protein, sinking through the eternal dark. When it finally hits the bottom, when it impacts the pale, silty mud of the abyssal or hadal plain, it is a revolutionary event, a cataclysm of abundance. In a single, instantaneous moment, a single point on the barren, nutrient-poor, patient mud is gifted with more organic material, more energy, more food than it would normally see in hundreds, or perhaps even thousands, of years. It is a mountain of flesh, a continent of calories, a feast of biblical proportions. And then the feast begins. This feast, this whale fall, happens in distinct, fascinating, and highly specialized stages. Each stage has its own community, its own set of adapted creatures, its own ecological rules. It is a succession, like the regrowth of a forest after a fire, but in reverse and in the deep. First, the mobile scavengers arrive. The call goes out through scent. The chemicals from the decaying carcass drift through the water, a plume of delicious information. Any creature that can move quickly, that can detect that plume, that can travel any distance, converges. The ghostly snailfish, the supergiant amphipods, swarming in their thousands. And if the depth is right, if the whale has fallen within their range, the slow-moving, ancient, mysterious sleeper sharks of the deep, creatures that can live for centuries, that are almost never seen alive, they arrive in a frenzy, a chaotic, violent, feeding frenzy in the absolute dark. They tear, they bite, they swallow. They strip the carcass of its soft tissue, its muscle, its blubber, its organs. This is the chaotic, violent, mobile scavenger stage, and it can last for many months, or even a couple of years, until the bulk of the flesh is gone, stripped down to the bone. Then, when the large scavengers have moved on, their bellies full, their journey done, the second wave arrives. These are the opportunists, the smaller creatures. The area is now fundamentally changed. The surrounding sediment is soaked with liquefied fat, with proteins, with nutrients from the decay. It is enriched, fertilized, transformed.
This enriched mud attracts a new community of smaller, slower creatures. Crabs, worms, small crustaceans, gastropods. They don't feed on the whale itself, not directly.
They feed on the now rich soil, on the bacteria blooming within it, on the organic soup that surrounds the skeleton. This stage, the enrichment opportunist stage, can last for several years. Finally, the most alien, the most specialized, and the longest stage begins. All that remains of the whale, after the scavengers and the opportunists have had their fill, is the skeleton. The bare, white, clean-picked bones. But the bones are not empty. They are not inert. They are packed with rich, energy-dense fats and oils, lipids that can sustain life for decades. Now, a specialized community of chemosynthetic bacteria arrives. They begin to break down these bone lipids, these fats, in a process that releases hydrogen sulfide, the same chemical, the same energy source that fuels the black smokers, the hydrothermal vents. The bones themselves become a new, temporary hydrothermal vent, a chemosynthetic oasis on the barren plain. This chemical release, this hydrogen sulfide, feeds a new community. A strange, plant-like worm called Osedax, the bone eater, or the zombie worm, lands on the bones and bores into them, using acidic secretions to dissolve the bone and reach the fat within. Clams, mussels, and other chemosynthetic creatures begin to grow directly on the skeleton itself. The whale's own bones, the remnants of its massive body, have become a living, breathing, thriving reef, a city of life in the desert of mud. This final, specialized, chemosynthetic ecosystem, this reef of bone and bacteria and clams and worms, can last for 50 years, for 70 years, for 100 years. A single whale fall is not just a meal, it is not just a feeding event, it is the creation of a temporary, isolated, self-contained island of abundance. A complex, evolving, multi-stage world that persists for a human lifetime. A way for life to create hotspots of diversity, of energy, of opportunity in the endless, cold, patient mud. And a single, massive death in the light, the death of a single animal, creates a new, thriving world in the dark that can last longer than most human marriages, longer than most human careers, longer than most human memories. A whale fall is a natural event. It is part of the cycle of life and death, the great, ancient, patient recycling of the ocean. It has enriched the abyss, provided oases for its creatures, and driven its evolution for millions of years, long before we ever existed. But the trench's most defining feature, its extreme, crushing, absolute isolation, has made it a candidate for other, less natural, less ancient, less benign objects. Objects dropped by a species that has only recently appeared on the surface, but whose reach has extended, without planning, without intention, to the very bottom of the world. For human history, for all of our time on this planet, the deep ocean has always been the perfect hiding place. The ultimate, final, unreachable storage. And the Mariana Trench is, by definition, by its very nature, the deepest, most secure, most permanent, most unreachable hiding place on the entire planet. If you wanted to drop something you never, ever wanted to be seen again by human eyes. Something you wanted to erase from the world, to make disappear completely, to ensure that no one would ever find it, no matter how hard they looked. Where would you put it? You would not bury it on land. Land can be dug up. You would not throw it in a river. Rivers lead to the sea, but the sea can be dragged. You would not sink it in shallow water. Shallow water can be dived. You would put it 7 miles down. You would put it in the crushing, absolute dark. You would drop it into the Challenger Deep. This is not just a modern idea. This dark, strategic, almost paranoid value was recognized almost as soon as the trench's true, mind-boggling depth was known. And that discovery, that measurement, happened at the precise, unfortunate moment when humanity was entering its most paranoid, most secretive, most dangerous era. The Cold War. This is where the verifiable facts end and the deep, unsettling speculation begins. The evidence is fragmentary. The records are sealed. The witnesses are silent or dead. But the logic is cold and clear. We know that the United States Navy, which funded, owned, and operated the Trieste, the first vessel to reach the bottom, had an intense, multifaceted, and largely classified scientific and strategic interest in the Mariana Trench. They were not just curious about the depth. They were not just funding pure oceanography. They were thinking about the Cold War, about nuclear submarines, about sonar, about hiding places and listening posts. But what was the true nature of that interest? What were they really doing down there? Theories have circulated for decades, whispered in oceanography departments and naval blogs. The most common, the most persistent, is that the trench was used as a graveyard, a classified, unreachable, permanent disposal site. In the high-stakes, high-technology, high-paranoia game of Cold War espionage, things went wrong. Experiments failed. Spy planes crashed into the ocean. Prototypes malfunctioned. And sometimes, rival technology was captured. A Soviet submarine, damaged or sunk, might be located. A piece of wreckage, a spy camera, a nuclear warhead might be recovered by one side or the other. What do you do with a failed, top-secret prototype that you don't want your enemy to know about? What do you do with the wreckage of a Soviet craft that you have secretly recovered and you don't want them to know you have it? What do you do with a nuclear warhead that has gone missing that you don't want to admit you lost? You can't bury it on land. It might be found, or dug up, or detected. You can't just sink it in the ocean. It might be recovered by the other side, or by curious oceanographers. But if you tow it, carefully, secretly, over the Mariana Trench, and you scuttle it, if you drop it into the Challenger Deep, it is gone. Forever. It is an object erased from the world, protected by a lock not of steel or code, but of 16,000 pounds per square inch of pressure. A pressure that no human diver could survive, that no conventional submarine could reach, that would crush any unauthorized recovery attempt into a crumpled ball of metal. It is the perfect, permanent, unreachable vault. And then there is the sound. We spoke earlier of the deep sound channel, the trench's bizarre, almost magical ability to carry sound, to amplify it, to guide it for thousands of kilometers across the ocean. The United States Navy, in the 1960s, during the height of the Cold War, knew this better than anyone. They were, at that very moment, deploying a secret, global network of underwater hydrophones, a listening system called SOSUS, the Sound Surveillance System. SOSUS was built for one purpose, and one purpose only, to track the movement of Soviet submarines. To listen for their propellers, their pumps, their hull noises from thousands of miles away. It was a network of listening posts, of arrays of hydrophones placed on the seabed in strategic locations around the world. And it worked. It could hear a Soviet submarine leaving port in Murmansk from a station in Newfoundland. It is a very logical, very plausible, if entirely unconfirmed, theory that this network would have been extended into or near the Mariana Trench. The trench, with its unique sound-channeling properties, its ability to carry sound for vast distances, would be the perfect, naturally amplified listening post for the entire Western Pacific. A place where you could hear every submarine, every ship, every large animal, for thousands of miles in every direction. Are there still classified, active, passive acoustic arrays down there? Hidden in the silt, buried in the mud, listening? Are there sensors, placed decades ago, still running on long-life nuclear batteries, still sending their data back to some secure listening station on a Pacific island? We may never know. The records, if they exist, are almost certainly sealed, classified for decades, perhaps for centuries. These are not stories of monsters or phantoms. These are not legends or myths. They are stories of a very human kind of secrecy, a very human kind of fear. The logic is cold. The logic is clear. The trench is a military asset, a strategic location, a tool, as much as it is a scientific wonder. And it is highly likely, almost certain, that down in that dark, ancient mud, buried beneath the natural debris, beneath the whale bones and the marine snow and the shells of dead plankton, lie other, harder, more angular, more artificial objects, the refuse of a global conflict, the secrets of a paranoid age, dropped there by the surface world in an era of fear to be forgotten. But those potential military secrets, those intentionally hidden, deliberately forgotten objects, are perhaps only a small part of a much larger, much more troubling, much more accidental story.
The trench's extreme isolation, its unreachability, made it a target not just for things we wanted to hide on purpose, but for things we simply, carelessly, negligently wanted to forget. For the trash we didn't want to deal with, for the waste we didn't know what to do with, for the poison we hoped would just go away. For most of the 20th century, for the entire post-industrial era, the deep ocean was treated by the industrial world as an empty space, a void, a convenient, near-infinite, bottomless pit. The philosophy, if it can be called that, was simple, short-sighted, and almost universally accepted. Out of sight, out of mind. We believed, with a kind of naive, almost childlike confidence, that the sheer, vast volume of the ocean would dilute our problems to nothing. That the deep was so large, so immense, that anything we put into it would be scattered, dispersed, rendered harmless. We believed that what sank into the deep would, for all practical purposes, simply disappear, like magic, like it never existed, and so we dumped, across the globe, for decades. We used the deep oceans as a default landfill, a free, unregulated, invisible dumping ground for the unwanted byproducts of our civilization. We dropped millions of tons of industrial chemicals.
Heavy metals like mercury, lead, cadmium. Toxic organic compounds like PCBs and dioxins. We scuttled ships filled with leftover, unwanted chemical weapons from old wars. Mustard gas, nerve agents, blistering agents, sealed in barrels, loaded onto old ships and sent to the bottom. We dropped millions of tons of munitions, unexploded bombs, artillery shells, landmines into the deep, because it was cheaper than disposing of them properly. And then there was the most difficult, the most dangerous, the most haunting waste of all. Radioactive material, the byproduct of the nuclear age. From the 1940s, from the very dawn of the atomic era, through the 1950s, the 60s, the 70s, and into the 1980s, many nations, including the United States, the Soviet Union, the United Kingdom, and others, saw the deep ocean as the most logical, the most practical, the most low-cost solution for their growing mountains of nuclear waste. It was a problem with no good solution on land. No one wanted a nuclear dump in their backyard. No one wanted it near their water supply. But the ocean? The ocean was vast. The ocean was deep. The ocean belonged to everyone, and therefore to no one. They sealed low-level, and in some cases, high-level, radioactive slurry, contaminated materials, used reactor components, even entire, decommissioned nuclear submarines into steel drums. They often encased the drums in concrete to make them sink, to make them last. And they simply loaded them onto ships, sailed out into the deep ocean, far from land, far from shipping lanes, far from prying eyes, and dropped them over the side, into the abyss. The Mariana Trench, being the deepest, most remote, most inaccessible place in the ocean, was not immune to this logic. It was, in fact, a prime candidate. A perfect location. If you wanted to make absolutely sure that your nuclear waste would never be found, never be recovered, never be seen again, you would put it at the bottom of the deepest hole on the planet. You would drop it into the Challenger Deep. The logic, at the time, seemed sound, almost reasonable. The trench was geologically stable, or so they believed. It was remote. It was deep. The waste would be isolated from humanity forever. The pressure would contain it. The cold would preserve it. The miles of water would shield the surface from any radiation. It would be safe. It would be forgotten. But this logic, this comforting, convenient logic, we now know, was deeply flawed, dangerously flawed. The ocean does not forget. The pressure does not contain. The cold does not preserve forever. Those steel drums, the ones they sealed with such confidence, were not designed to last for millennia. They were industrial containers. They were designed to last for a few years, a few decades at most. They were certainly not designed to withstand the combined, relentless assault of corrosive salt water and 16,000 pounds per square inch of crushing pressure. The pressure buckles them. It deforms them. It pops their seals. The salt water, the universal solvent, the great dissolver, rusts them, corrodes them, eats through the steel over the decades. They corrode. They implode. And they leak. And the
Challenger Deep, the place they chose for its isolation, for its permanence, turns out to be perhaps the worst possible place for a leak. It is not an open, flat, featureless plain where currents can disperse and dilute the contamination. It is not a place where the poison can spread out and become harmless. The trench is a deep, steep-sided, V-shaped trap. It is a funnel.
It concentrates everything that falls into it. It holds it. It contains it. It does not let go. The toxic materials, the heavy metals, the organic poisons, the radioactive isotopes, they do not just wash away. They do not dissipate. They leak out of the corroding drums, seep into that fine, pale, silty sediment, and settle there. They become part of the mud, part of the floor of the world, and from there they are absorbed by the simplest, most fundamental forms of life. They are taken in by the giant amoebas, the xenophyophores, as they slowly sift through the sediment. They are ingested by the amphipods, the supergiant scavengers, as they crawl across the mud. They are filtered by the sea cucumbers, the glass sponges, the deep-sea worms. They quietly, invisibly, inevitably enter that slow, patient, energy-starved food web. They become part of the ecosystem. They become part of the abyss. We went looking for an alien world, a place of phantoms and strange biology, a place of giants and glass creatures, a place untouched by time and unknown to humanity. But what we are finding, buried in that pale, ancient silt, is a quiet, uncomfortable, unmistakable echo of our own industrial age, our own carelessness, our own refusal to deal with our own waste. We have not discovered an alien world. We have discovered a mirror, and the reflection is not flattering. And yet our relationship with the trench, our strange, complicated, contradictory relationship with this deepest, darkest, most alien place on our own planet, is perhaps about to enter a new and even more complicated phase. A phase that could determine the future of this unique, ancient, fragile ecosystem. We have used the trench as a dumping ground, a place to discard what we feared or what we no longer wanted, a place to hide our secrets and forget our waste. Now, we are beginning to look at it differently, not as a garbage can, but as a treasure chest. The irony is sharp, bitter, and almost unbearable. The very same features that create such unique, strange, extraordinary life in the abyss, the hydrothermal vents, the black smokers, are the source of this new, intense, industrial desire. When that 400-degree, mineral-rich, superheated fluid from the Earth's mantle hits the cold, near-freezing seawater of the trench, it creates those billowing, dramatic clouds of black smoke. But when that smoke settles, when those dissolved minerals precipitate out of the hot fluid and fall to the seabed, they do not just form a thin, scattered dust over thousands of years. They build up, they accumulate, they form massive, solid, towering deposits around the vents, chimneys of rock built from the dissolved minerals of the Earth's interior. These deposits are called polymetallic sulfide chimneys, and they are essentially, for all practical purposes, highly concentrated ore. They are natural, pre-processed, almost pure mineral deposits. They are packed with valuable metals, copper, zinc, lead, silver, and gold. The stuff of electronics, the stuff of industry, the stuff of wealth. But more importantly, for our 21st century, high-tech, digital economy, they are extraordinarily rich in rare earth elements. The minerals we barely knew existed 50 years ago, and now cannot live without. The neodymium in the powerful magnets of an electric car's motor, the dysprosium in the same magnets, the terbium in the green phosphors of a laptop screen, the europium in the red phosphors, the cerium in the catalytic converter of a car, the lanthanum in the battery of a hybrid vehicle. These are the minerals that power our modern lives. They are essential. They are strategic. And on land, they are becoming harder, more expensive, and more politically complicated to find and extract. The easy deposits are gone. The remaining ones are in difficult, unstable, or protected places. There are trade wars over rare earth elements. There are diplomatic disputes. There is, quietly, a global scramble. But in the deep ocean, in the Mariana Trench, around the hydrothermal vents, these minerals are just sitting there, piled high, unclaimed, unguarded, waiting. This has triggered what many are calling, with only a little exaggeration, a new gold rush. A quiet but frantic technological race to the bottom of the ocean. Dozens of nations and private corporations are at this moment designing, building, and testing the machines to do it. The technology is advancing rapidly. The economic incentives are enormous. The political will is building. We are talking about giant robotic harvesters, submersible grinders and bulldozers, each the size of a small building or a large truck. They can be lowered 7 miles down on a cable and operate in total darkness under crushing pressure without human intervention. Their purpose is simple, brutal, and efficient. They land on the seabed, on the delicate, ancient, life-filled chimneys of the hydrothermal vents. They extend their cutters, their grinders, their suction heads, and they systematically grind the vent chimneys into slurry, a thick, watery, mineral-rich sludge. This slurry is then pumped up a massive, high-pressure hose, miles and miles long, to a processing ship on the surface. The ship separates the valuable minerals from the water, from the mud, from the crushed remains of the vent. The water is pumped back down. The minerals are loaded onto barges and taken to refineries. The vent, the unique, irreplaceable, millions of years old structure, is gone, reduced to pulp. The plan is, in effect, to begin the strip mining of the deep ocean floor, to treat the most extreme, most fragile, most poorly understood ecosystem on Earth as a quarry, as a gravel pit, as a source of raw materials to be extracted and sold. The consequences of this, if it proceeds, are difficult to overstate. They are not just local. They are not just temporary. They are potentially catastrophic, because these vents are not just rocks. As we have learned, as we have seen with our own cameras and submersibles, they are the oases of the abyss. In the cold, dark, nutrient-poor desert of the deep ocean floor, the hydrothermal vents are the only points of concentrated energy, of concentrated life. They are the only places where the food web is not dependent on the slow, thin rain of marine snow from the surface. They are independent worlds, islands of chemosynthetic abundance in a sea of starvation. This kind of mining, this industrial-scale grinding and removal of the vents, would not just disturb the ecosystem. It would not just damage it. It would annihilate it. Completely. Totally. Irreversibly. It would be the equivalent of bulldozing an entire, unique, irreplaceable rainforest. A rainforest that had taken millions of years to evolve, to get at the soil underneath. The giant tube worms, the ghostly white crabs, the blind shrimp, the shimmering mats of chemosynthetic bacteria, the entire, unique, strange, wonderful food web that lives on the energy of the Earth itself would be instantly destroyed. Their habitat would be gone. Their chemical energy source would be disrupted. They would have nowhere else to go. These are not mobile, adaptable creatures. They are specialists, evolved over millions of years for one specific, tiny, unique environment. When that environment is gone, they are gone. Extinct. And the damage would not be contained. It would not stay within the boundaries of the mining claim. The mining process, the grinding, the crushing, the suction, would kick up vast, choking clouds of sediment. Plumes of fine, silty, toxic material. These plumes would not just settle back down where they were created. Ocean currents, slow but persistent, would carry them. They would drift for miles, for tens of miles, for hundreds of miles. They would settle, slowly, gently, on the surrounding seabed. They would bury, suffocate, and poison neighboring ecosystems, neighboring vents that were not even the target of the mining. The destruction would spread. The oasis would become a dead zone. We are standing on the verge, on the precipice of being able to systematically, efficiently, profitably remove an entire, unique, ancient, irreplaceable biosphere. A world we have only just discovered. A world whose existence we have only known for a few decades. A world that might hold the secrets to the origin of life itself, to the evolution of metabolism, to the possibility of life on other planets. All of that knowledge, all of that wonder, all of that ancient, patient, strange life would be sacrificed. For what? for the raw materials to build our next generation of smartphones, for the cobalt in our batteries, for the neodymium in our electric cars, for a few more years of economic growth. And yet, this destructive, short-sighted, industrial-scale gold rush, this modern-day version of tearing down the temple to get the gold leaf, is not supposed to be possible. Not here. Not in the Mariana Trench. On paper, on the maps, in the law, the Mariana Trench is not some lawless, unregulated frontier open to any corporation with a big enough machine. It is, in fact, one of the most highly protected marine environments on the entire planet. In 2009, under President George W. Bush, the vast majority of the Mariana Trench and its surrounding waters, including the Challenger Deep itself, were designated as a marine national monument. The Marianas Trench Marine National Monument. It is a protected sanctuary, a national park of sorts for the deep. This designation sounds powerful. It sounds absolute. It conjures images of a pristine, untouchable, inviolate wilderness, a place set aside, protected by law, guarded by the authority of the United States government. It legally prohibits commercial fishing, mineral extraction, and most importantly, for our purposes, resource extraction like deep-sea mining. Within the boundaries of the monument, mining is illegal. But this protection, like the map of the trench itself, runs into a difficult, inconvenient, perhaps insurmountable reality. The first, most obvious problem is enforcement. A national park on land has rangers. It has fences. It has gates. It has borders that can be seen and patrolled. How do you patrol a place that is 7 miles deep? How do you put up a fence on the bottom of the ocean? How do you station a ranger at the Challenger Deep? How do you see a mining operation happening in the absolute, crushing, lightless dark under 16,000 pounds per square inch of pressure? The sheer, staggering logistical challenge of enforcing any law at that depth is almost impossible to overstate. It would require a fleet of submarines, a network of sensors, a constant, expensive, high-tech presence. And even then, how do you stop a robotic deep-sea harvester from a rival nation, or from a private corporation operating under a flag of convenience, from accidentally or deliberately straying into protected waters? The answer is, with great difficulty. Perhaps with impossibility. But the more profound, more fundamental problem is one of jurisdiction. The ocean is not owned. It is not like land. No one has a deed to the Pacific Ocean. While the U.S. Marine National Monument covers a vast area of the trench itself is a long, complex, sinuous geological feature. Parts of it, and the resource-rich areas surrounding it, the areas most attractive to mining companies, lie not within U.S. territorial waters, but in what are known as international waters, the high seas, the areas that belong to no nation, and therefore, in practice, to everyone. And in those international waters, a different authority rules. A global, somewhat obscure, but increasingly powerful body called the International Seabed Authority, or ISA. This is the organization, established under the United Nations Convention on the Law of the Sea, that is in charge of managing the deep ocean floor, the seabed beyond national jurisdiction. The area that belongs to all of humanity, collectively. And critically, the ISA is the very body that is currently writing the rules for deep-sea mining. They are not opposed to mining. Their mandate is not to prevent it. Their mandate is to regulate it, to manage it, to ensure that it is done in a way that is for the benefit of mankind. They are the ones granting the exploration licenses. They are the ones allowing corporations and nations to test their mining equipment. They are the ones deciding, right now, what the environmental standards will be, how much damage will be allowed, and who will be liable when things go wrong. This creates a strange, bureaucratic, and deeply troubling paradox. A protected sanctuary, a national monument, established by one nation, the United States, that is bordered and perhaps even overlapped by a potential mining claim from a different international authority. Who has the final say? Whose law applies? What happens when a mining operation licensed by the ISA happens to drift or to claim an area that is technically inside the US monument? The legal battles could last for decades. The trench could be tied up in international courts while the mining continues. And even if the mining happens just outside the protected border, just outside the monument, the physics of the ocean, the chemistry of the water do not respect human laws.
You cannot stop the pollution. You cannot put up a fence around a plume of toxic sediment. The clouds of silt and heavy metals and disturbed chemicals kicked up by the mining operation, they will drift. Ocean currents, the deep, slow, relentless circulation of the abyss will carry them. They will not stop at the invisible line on a map. They will flow across it, settle within it, and bury, suffocate, and poison the very ecosystems that the monument was established to protect. The designation of a national monument, the drawing of a line on a map, is a necessary and noble gesture. It is a statement of intent from the surface world, a recognition that this place is special, that it deserves protection, that it is worth preserving.
But in the cold, pressurized, dark, and silent reality of the abyss, 7 miles beneath the waves, it is genuinely, deeply, unsettlingly unclear if that line can truly protect a place we can barely even see, a place we have visited only a handful of times, a place that remains, in so many ways, completely unknown. It is not surprising, then, that this place, this trench, this abyss, so deep, so dark, so hostile, and so fundamentally defended by its own physics, has captured the human imagination in a way that goes far beyond science or law or economics. When a place on our own planet remains this unknown, this powerful, and this resistant to our presence, it ceases to be just a location on a map. It becomes a symbol, a metaphor, a mirror. It becomes a screen onto which we project our deepest, most primal, most ancient anxieties. Long before the Trieste ever descended, before the black smokers were discovered, before we had any real idea of what was down there, before we had sonar or submersibles or even a clear measurement of the depth, the human imagination was already at work, filling the blank spaces with monsters. The writer H.P. Lovecraft, working in the 1920s in a quiet, overlooked corner of American pulp fiction, was searching for a concept to anchor his new, strange, and deeply influential mythology. He was not interested in common ghosts or simple monsters or the traditional horrors of Gothic literature. He was interested in a far greater, far more philosophical, far more unsettling kind of fear, the fear of the cosmic, the fear of the vast, the fear of the unknown, not as something that will hurt you, but as something that simply does not care. The terrifying, humbling, almost unbearable realization that the universe is ancient, immense, and completely, utterly, absolutely indifferent to humanity, to our hopes, our fears, our loves, our deaths. He called this fear cosmic horror, and he needed a symbol for it, a physical place where that indifference could be felt, could be imagined, could be almost touched. In the 1920s, he wrote of ancient, godlike, immensely powerful beings called the Great Old Ones. Beings that existed before humanity, that will exist after humanity, that see us as we see insects. And when it came time to imagine a prison for the most powerful, the most famous, the most enduring of these beings, Cthulhu, he did not choose a distant galaxy, or another dimension, or a far-off star. He chose the deep Pacific, the unexplored, unknowable, unimaginable abyss. He invented a fictional, sunken city, a place of nightmare architecture and non-Euclidean geometry called Aurelie. And there, in the dark, under the crushing pressure, in the absolute cold, the dead god Cthulhu lies dreaming, waiting, not sleeping, but dreaming. And his dreams, Lovecraft wrote, leak up to the surface, influencing sensitive minds, causing madness, inspiring cults, waiting for the stars to come right, for the prison to open, for the surface world to be reclaimed by the ancient, indifferent powers of the deep. Lovecraft had never heard of the Mariana Trench, not by name. The measurements of its true, staggering depth came later. But he had, perhaps instinctively, perhaps intuitively, tapped into something real, something powerful. He understood, without the science, that the deep ocean is not just a place. It is an idea. It is the truest, most accessible, most physical embodiment of the unknown. He understood that the truest horror is not an active, malevolent evil, a monster that chases you with teeth and claws. The truest horror, the deepest fear, is an indifference that has been here all along. A universe that does not know you exist and would not care if it did. The Mariana Trench is the real-world, tangible, physical embodiment of that idea. It is a place that exists on our own planet, that we could, in theory, visit, but that remains, in practice, alien. It is a world that existed for billions of years before the first fish crawled onto land, before the first mammal suckled its young, before the first human looked up at the stars. It will exist for billions of years after the last human is gone, after our cities have crumbled, after our plastic bags have degraded, after our nuclear waste has decayed. It is a place that does not know we exist, that has no record of our passage, that would not notice our extinction. The pressure is not evil. It is just a law of physics. The darkness is not malevolent. It is just the absence of a sun it has never known. The cold is not cruel. It is just the temperature of a world without warmth. This is the trench's cultural power, its psychological weight. It is the last remnant of a truly alien Earth, existing right here, within our own world, within our own bodies of water. It is the physical manifestation of the great, unsettling, humbling unknown. The place where our maps end. The place where our certainties dissolve. We can send our probes. We can draw our maps, however vague. We can even write our laws, establish our monuments, draw our lines in a noble but perhaps futile attempt to protect it. But the abyss, the trench, the hadal zone, it just waits. It does not resist. It does not fight. It simply endures. It dreams its own slow, cold, patient, geological dreams. It is this profound, ancient, absolute indifference that makes it the perfect cellar for the planet. A place where the human imagination, confronting its own limits, its own smallness, its own mortality, stores its deepest, most primal fears. That feeling, that Lovecraftian sense of an alien world, of a place that follows different rules, that does not care about us, is no longer just a fantasy, just a literary trope. It is not just a subject for horror stories. In a strange, unexpected, and deeply fascinating twist, modern science, astrobiology, the search for life beyond Earth, is now looking at the Mariana Trench for almost exactly that reason. As a model, as an analogue, as a window into what life might be like on other worlds. We are, as a species, collectively, obsessively, perhaps hopelessly, driven by a single, fundamental, defining question. Are we alone? Is this pale blue dot, this tiny, fragile, beautiful planet, the only place in the vast, silent, ancient universe where life has taken hold? Or is the universe teeming with life, with alien biologies, with strange creatures, with other intelligences? To answer this question, we are no longer just looking at distant, Earth-like planets orbiting other stars, planets we can barely see, planets we will never reach in our lifetimes. In recent years, our hopes, our attention, our spacecraft designs have focused on a new, much closer, and perhaps much more promising target: the icy moons of our own solar system. We are speaking, specifically, of Jupiter's moon, Europa, and Saturn's moon, Enceladus. These are worlds that are, on their frozen, radiation-blasted surfaces, completely, utterly hostile to life as we know it. They are frozen balls of ice, locked in a deep, permanent, cryogenic freeze, with surface temperatures of -160 degrees Celsius or colder. They are bombarded by the intense, deadly radiation of their parent planets. They are airless, sterile, dead. But beneath those miles-thick, icy, shell-like surfaces, we are now almost certain, based on magnetic field data, on gravity measurements, on the plumes of water vapor erupting from Enceladus's south pole, that there are vast, global, liquid water oceans. Oceans that are kept liquid not by the distant, faint, feeble warmth of the sun, but by the gravitational pull of their giant planets. This constant, flexing, tidal tug-of-war, as the moons are stretched and squeezed in their orbits, generates immense heat from internal friction. It warms the rocky cores of these moons, melts the ice, and creates a dark, cold, pressurized, liquid ocean trapped beneath a shell of ice, completely cut off from the surface, completely cut off from the sun. A dark, cold, liquid ocean, heated from below by geothermal energy, pressurized by the weight of the ice above, rich in minerals, in chemicals, in dissolved compounds leached from the rocky core. This should sound, by now, deeply familiar. It is the exact, precise, almost perfect model of the hydrothermal vent systems we have found in our own deep ocean. The same conditions.
The same energy source, the same chemical gradients, the same potential for life. If we are going to find life on Europa, if we are going to design a probe that can survive the journey, land on the ice, melt its way through miles of frozen shell, and explore that dark, alien ocean, we must first look to the Mariana Trench. It is our best, our most accessible, and perhaps our only model for what extraterrestrial life might actually look like. It is our planetary analog, our testbed, our Rosetta Stone. Life on Enceladus, if it exists, will not be a photosynthesizing plant. There is no sun. It will not be a complex, vertebrate fish. The energy budget is likely too low. It will be, in all likelihood, a chemosynthesizing microbe, a bacterium or archaeon thriving on the sulfur, the methane, the hydrogen, the dissolved minerals of a deep-sea hydrothermal vent. Just like the tube worms, the blind crabs, the shimmering mats of bacteria in our own black smokers. Not the same species, not the same lineage, but the same strategy. The same solution to the same problem. Life on Europa will not be a whale or a shark. It will not be a complex, multicellular animal with eyes and a nervous system. But if it has evolved beyond the microbial stage, if it has achieved multicellularity, it will have had to solve the same identical problems that our own deep-sea creatures have solved. It will need to be a creature built of pressure. Its cells will need to be protected by those same or similar specialized molecules, the piezolites, to prevent its proteins from unfolding. Its body, if it has a body, will likely be soft, gelatinous, in a kind of delicate, precise, evolutionary equilibrium with its crushing, dark, high-pressure environment. It will, in other words, look like the snailfish, or the glass squid, or the giant amoeba. Not in detail, not in evolutionary history, but in form, in function.
In the solutions that physics and chemistry impose on all life, everywhere, in the deep. The Mariana Trench has, in this strange, unexpected, almost circular way, become a field of applied astrobiology. We are studying its dark, cold, pressurized, lightless ecosystems, not just to understand our own planet, not just to catalogue its strange creatures, but to prepare ourselves for the discoveries we hope to make on other worlds, to train our instruments, to calibrate our expectations, to learn to recognize alien life when we see it, because we have already studied its close cousin, here, at home, under the Pacific. The trench has taught us a profound, humbling, and hopeful lesson. It has taught us that the sun is not an absolute, universal requirement for life. There is a second, separate, independent way to power a biosphere, the energy of the Earth itself, the slow, patient, chemical energy of the planet's interior. It has taught us that extreme pressure, the crushing, suffocating, impossible weight of a deep ocean is not a barrier to life. It is just a different set of rules, a different evolutionary challenge, a different path to adaptation. And it has shown us definitively, conclusively, that if life can take root, can thrive, can diversify, can create complex ecosystems in a place as impossibly, absurdly difficult as the Mariana Trench, then it is no longer quite as much of a stretch, quite as much of a leap of faith, to imagine it taking root in the cold, pressurized, mineral-rich darkness of a distant, icy, alien moon. If life can exist here in the hadal zone under 16,000 pounds per square inch without a ray of sunlight, without a breath of oxygen, feeding on sulfur and rock and the slow, faint rain of dead things from above, then it can exist elsewhere. The universe may not be a sterile, silent void. It may be a garden of dark, hidden, patient oceans, each with its own strange, slow, invisible ecosystem. But how will we explore these new worlds, both our own, still largely unknown trench, and those distant, icy, alien moons? The age of the heroic, solo, manned descent, the age of the Trieste and the Deep-Sea Challenger, of Picard and Walsh and Cameron may already be over. It may have been a brief, bright, beautiful moment in the history of exploration, and then it ended. These were incredible, singular, awe-inspiring moments driven by human courage and human curiosity and human wealth. But they were also extraordinarily risky, incredibly expensive, and, from a purely scientific, data-gathering perspective, inefficient. A human being is a fragile, complicated, demanding passenger.
We are, after all, surface creatures. We breathe air. We need warmth. We need food. We need psychological comfort. We are not built for the hadal zone. We are not adapted to the crushing pressure. We are, in that environment, a problem to be solved. And the engineering required to protect us, to keep us alive, to bring us back, is a monumental, expensive, and limiting barrier. It restricts where we can go, how long we can stay, and what we can bring back. The future of deep-sea exploration, of hadal exploration, of the exploration of the Mariana Trench and all the other deep places on Earth, and, by extension, of the exploration of Europa and Enceladus, is not human. It is, increasingly, obviously, inevitably, robotic. But this is not the future we once imagined.
It is not the clunky, remote-controlled, tethered, slow-moving robot of the 1970s, dragging a heavy cable, dependent on a ship above, limited by the length of its leash. The new generation of explorers, the ones being designed and built right now in laboratories and engineering shops around the world, are being designed to be something else, something smarter, something smaller, something more resilient, and, most importantly, something free. Engineers are now developing fleets of small, autonomous, AI-driven submersibles. They are not the size of a bus or a truck. They are the size of a shoebox, or a loaf of bread, or a softball. They are cheap to build, cheap to deploy, and, if lost, cheap to replace. And many of these new designs are soft-bodied robots. Their engineering, their materials, their movement is inspired by the very creatures that live in the deep. The squid, the octopus, the snailfish. They are being built not to fight the environment, not to resist the pressure with heavy, rigid, metal shells, but to be part of the environment, to move with it, to flex and flow and adapt, to become, in a sense, animals. The idea is to stop sending one single, multi-million-dollar, heavily armored, high-risk vehicle, and instead to release a swarm. Imagine a support ship on the surface, a relatively small, inexpensive vessel anchored over the Mariana Trench. It releases not one probe, but 100. 100 small, intelligent, autonomous submersibles. They are not connected to the ship by cables. They are not controlled by human pilots in real time. They are dropped, and they are free. They descend together, a scattered cloud of tiny, glowing, searching machines falling through the darkness. They communicate with each other through simple, low-energy pulses of light or sound. They share information. They coordinate. They are not individuals, but a collective, a distributed intelligence. They do not need a pilot. Radio control from the surface is impossible at that depth. Water is an almost perfect barrier for radio waves, so the robots must be able to make their own decisions. They must be smart enough to navigate, to avoid obstacles, to identify targets, and to share what they find. This is where artificial intelligence, the same kind of AI that powers self-driving cars and facial recognition, becomes a necessity, not an option. The robots must see, interpret, and act all on their own, in real time, in the crushing dark. One probe, drifting over a rocky outcrop, detects a chemical anomaly, a trace of hydrogen sulfide, a plume of warm water. It recognizes the signature of a hydrothermal vent. It alerts the swarm. A dozen other probes, nearby, change course. They converge on the location, communicating, coordinating. They descend together, mapping the vent in 3D, creating a virtual model of the chimney, the tube worms, the blind crabs. They take chemical samples, water samples, biological samples. They record video, audio, temperature, pressure. They do all of this without a single human command. They are exploring on their own in the dark. If one probe is lost, if it is crushed by the pressure or trapped in a crevice, the mission does not end. The swarm learns from the loss. It adapts. It continues. The loss of a single, cheap, disposable unit is not a catastrophe. It is data. This is how we will finally, truly, begin to fill in the blank spaces on the map of our own planet. Not with a single, heroic, expensive spotlight, but with 1,000 tiny, patient, intelligent points of light moving and thinking together as one. And this is how we will search for life on Europa. We will not send a single, billion-dollar, heavily armored lander with a few instruments and a short lifespan. We will likely melt a hole through the ice using a nuclear-powered probe and once we have reached the liquid water below, we will release a swarm of tiny, autonomous, AI-driven submersibles designed to hunt, to search, to explore the dark, alien ocean beneath the ice, looking for vents, looking for chemical anomalies, looking for signs of life. They will be our eyes, our ears, our presence in that distant, hidden water world. The future of exploration, of discovery, of understanding the strange, alien places of our own planet and others is not about conquering the abyss. It is not about dominating it, or subduing it, or extracting its resources. It is about learning from it, about adapting to it, about building machines that are as resilient, as adaptive, as intelligent, and as patient as the strange, soft-bodied, gelatinous, beautiful life that has thrived there in the crushing dark for millions of years without us. We have travelled in our minds in this quiet, slow, shared hour to the very bottom of the world. We have descended past the last glimmer of sunlight, through the twilight, through the midnight, past the abyss into the hadal zone. We have followed the story of the first explorers and their cracked window. We have searched for a phantom fish that may or may not exist. We have met the true, strange, wonderful inhabitants of this realm, the ghostly, melting snailfish, the giant, single-celled architects, the transparent, glass-bodied creatures of the dark. We have seen the chemical oases of the black smokers, the deep-sea vents that may be the very cradle of life on Earth, the birthplace of everything that swims and crawls and walks and breathes. And we have also seen the shadows of our own world, cast long and dark into this remote place. The plastic bag drifting down from the surface, a synthetic ghost arriving before we did. The theories of military secrets, of hidden listening posts, of forgotten graveyards. The barrels of nuclear waste corroding and leaking in the pale, ancient silt. The coming, inevitable, perhaps catastrophic race to mine the seafloor, to tear apart the vents for their minerals, to sacrifice an entire, unique, barely understood biosphere for the metals in our next phone. We are, in our modern, connected, data-saturated age, a species obsessed with answers. We are uncomfortable, deeply, perhaps pathologically uncomfortable, with ambiguity. We have built a world of data, of satellites, of instant information, of search engines that answer any question in milliseconds. We strive, collectively, obsessively, to fill every blank space on the map, to solve every riddle, to leave no question unanswered, no mystery unsolved. We tend to see the unknown as a temporary problem, a failure of our knowledge, a gap that will eventually, inevitably, be filled by more technology, more data, more exploration. But this long, slow, quiet journey to the bottom of the Mariana Trench suggests something else, something perhaps difficult to hear, but important to consider. It teaches us that the unknown is not a failure. It is not a problem to be solved. It is, perhaps, a necessity, a requirement. A part of what it means to be alive, to be curious, to be human. The Mariana Trench's greatest secret, the most profound truth it holds, may not be a creature, or a sound, or a geological marvel, or a new species of giant amoeba. Its greatest secret may be mystery itself. The trench is the last great bastion of the truly unknown on our own planet. It is the physical, tangible, undeniable proof that we have not solved the puzzle, that our maps are still blank, that our knowledge is still incomplete, and perhaps always will be. It is the humbling, 7-mile-deep reminder that we are small, that the world we live on, this beautiful, fragile, ancient planet, is still, in its deepest, darkest, most inaccessible parts, a profound, wild, and indifferent wilderness, a place that does not know our names, a place that does not care about our empires, a place that existed long before us and will exist long after us. A world with no more secrets would be a smaller world, a poorer world. A world without genuine, deep, thrilling mystery would be a world without real curiosity. And curiosity, the restless, insatiable desire to know what is over the next hill, what is beneath the next wave, what is waiting in the dark, is the engine of our science, our art, our philosophy, our very humanity. It is the what if that pulls us forward. It is the maybe, that keeps us exploring. It is the quiet, persistent, beautiful voice that says there might be something more. We need the Mariana Trench to exist just as it is. We need to know that in an age of total surveillance, of drones and satellites and always-on cameras, there is still a place that cannot be easily seen, a place where the light does not reach, a place where the noise of our civilization is muffled, transformed, turned into a distant, haunting hum. In an age of constant, overwhelming, exhausting noise, we need to know there is still a place that holds its own deep, strange, ancient sounds. A place where the whale songs echo and the tectonic plates groan and the metallic, unexplained twangs of the biotwang defy our attempts to catalogue and classify. In an age where we feel, perhaps arrogantly, that we have mapped everything, that we have photographed every corner, that we have named every species, we need to be reminded that we have, in truth, barely scratched the surface. That most of our planet is still unexplored, that most of the life on Earth is still unknown to science, that the deep, the dark, the abyss is not a conquered frontier, it is a vast, patient, waiting wilderness. In the end, the true value of the abyss, the real treasure of the Mariana Trench, is not the minerals we can extract from it, or the military secrets we can hide in it, or the nuclear waste we can dump in it, or even, perhaps, the biological secrets we can learn from it. Its true value is its existence. It is the planet's final, quiet, ancient, and beautiful promise. A promise that there is always something deeper. There is always something more to discover. There is always another mystery, another question, another dark, unexplored place waiting patiently in the dark for us to come and wonder.